Oh, that made a pop noise. Sorry. I know it's a minimal pop, but it's still a pop. Okay. I'm here. Lights. Ooh, gotta calibrate the cameras. Where's that one looking? What the heck? Wake up, you've passed out of my shop. Ah. What's going on? Oh no, I'm popping, I see. All right. My levels are good though. Yeah, my levels are. Whoa, that was a little hot. Hold on one sec. That was a little poppy. I don't want to peek up into the red. Hopefully my retuning of the mic a little bit has helped out. Oh, the fan is making this camera shake. That's actually kind of fun. My weekend was good. I went to a friend's house in Westchester. Whole place is built like a fortress. It's insane. Let's see. Oh, the soldering iron's producing a little bit of heat, huh? I guess I used it yesterday, so... let's see. What else do we need? This one? Oh, yeah, that one's cooking. Well, let's just go through all the procedures. So this is the next one down the line. That does its thing. And we do this one. That should make things a little bit more palatable from the microscope. We're going to need it a little bit today because we're going to put in that remaining chip. And then we do this one. This one already looked okay. I should probably look up a new cadre of webcams that I can use. It'd be a big purchase, but it's something I should probably do. Hey, Matabu, your comment never went through because I didn't prime YouTube. It is primed now. It is primed now. Actually, wait, I need that window up for moderating purposes. Just in case some bad actor shows up in the YouTube. This is the DJ Shadow action adventure album, which is good background. It's good stream starts music. What's up, Godad? How you doing? How you doing? I need to clean up a little bit. I don't know if we're gonna do a cleanup stream or not. It's like something that I desperately need to do. Hey, Mahalo. It's something I desperately need to do because everything under here can probably move to another room because I don't immediately need anything. Everything under there has been there for over a year. So if I move all that stuff out and put it in the storage area, I can move all the printer stuff down. That printer will stay over there, but all that printer stuff can go down. And then I can bring in my hood. Yeah, the yearly licking of all the bench tops is true. I can move my Creality-sized hood down here, put it sideways, and do all the resin stuff in there. So the resin stuff can stay local. This control box also needs to just go. I haven't done anything with that in 6 years. That's the brewing controller right there. And I have a new control box for the brewing controller sitting behind it, but we've not gotten around to it. Those functionality panels, the doing one of those electrical panels is really fun, and we should do that at some point. But I just haven't had the room in my schedule to do it. We've had too many other things going on. Yeah, and then on the far end, I've got all those project bins that are starting to really become a hassle. They're getting less organized as time goes on, and so I need to pull all of those out and organize those because it's getting to be the season that Julian and Dave will be able to show up. And once they get here, I need a countertop for them, and I need to be a little bit more clean with the stuff around here. Yeah, it's just something that needs to happen. I don't know when I'm going to get around to it. I have too many. The VOD uploads have taken up all of that space in time where I go, nothing is going on. I should do something that'll help me down the line. All of that has been taken up by, I need to do my uploads. I need to do my uploads. So maybe I'll lapse in the uploads. It would be kind of a tragedy though if I mess up at like, this is like we're at the part where the head games come in. Right after that part is the push to finish, right? This is head games. Next, we have push to finish. So I have about 120 left to go. And that number doesn't seem to be going down. I don't know why. I can do 3 a day, but I haven't been keeping up with it. Some days I just can't, I can't face it. And it's not that much work, right? It's not hard work. I'm not like digging a ditch, you know? It's not hard work. All I have to do is hit skip right until I get to the next thing that's going on stream. But I just did that whole stream that we did where I updated Node-RED, which is fascinating for people who are interested in Node-RED, but it was a slog for me to figure out what was going on in that stream. Yeah, it is definitely a tasty album. This is the DJ Shadow Action Adventure is kind of a neat album. It's him kind of just becoming, I don't know, I would call it him like being more mature with the music. Because, you know, he does all the DJ stuff and he had all these cool, like, neat little beats and stuff. And they said, wait, what would music sound like if I kind of, like, authored it completely and figured out? I don't know. It's a fun album, though. Good stuff, good stuff. There's a Raspberry Pi 5 in the background there. And then in the foreground, we have the POS CNC. I was debating about the POS CNC if I didn't want to like cut any holes in the side of it. It would be funny if when the drivers got to a certain temperature and everything needed to cool off, the cache drawer would pop open. But in considering that it would be a CNC machine, I wouldn't want it to just suddenly serve up all the electronics to the chips on a literal platter. All the aluminum or wood chips that would come out of the thing. I don't think I'd want them to be served up on a platter. The POS CNC, I may have to put aside for a little bit. Because I think I want to use all the Granite Devices controllers if they fit. And that would mean it would have super high quality servos on a not so high quality CNC. But I've got these super high quality servos. What do I do with them? And then down the line, I guess I could replace the super high quality servos with regular stepper motors if I treat them as such. But like if I have the really high quality servos on the CNC machine, will I be able to do stuff to like a precision level that exceeds a normal CNC? And the answer is probably no, like because it's limited by the mechanics. The mechanics are what they are. Think about that. And then on top of all that, I finally got the air cleaners for this, for the SLA. Is that what it's called? SLA? One's a laser, the other one's not. Select LCD A, I don't know. The resin printer. Fix the mechanics and software. Wonder how much you could get away with that. If like a tooth was missing on one of your belts and all that stuff. But yeah, I want to get that resin printer up and functioning, but I don't want to gas myself out. So I'm going to put it inside of a hood and hopefully that doesn't do it. I saw Hajiwo dropped a new VCO. I saw the video. I didn't watch the video yet because Hajiwo's is fast becoming like Hackaday for me, where I'm not allowed to watch I'm not allowed to look at Hackaday because I'll buy stuff every single time I open up the website. It's a bad place to be. I end up getting into all these projects that I'm never going to do. So this is the bother needs to refocus and redouble his effort back on organizing his life. Otherwise, his show is just a pile of garbage. I'm literally sitting next to 2 piles of garbage on either side of me right now. I barely have maneuvering space on the floors because stuff has come out of shelves when I'm looking for things. It's a bad place to be. My whole life is a PSA towards not ending up where I am. Which is why it baffles me when people come in here and go, what do you do for a living? What's your job? How do you make money? What's your job? What do you do? I'm like, I sit on a pile of garbage and feel bad about my life. Like, what do you want from me? Oh, everything is flowers and you just get into, you take this test and suddenly fame, fortune, and riches will come your way. That's why I'm sitting in a basement on top of all this garbage. It's so easy to start shopping for projects that won't happen. It happens to all of us. I think it's a main facet of the community and the involvement and the just the mindset of your project doer You're like, I can do cool stuff with electronics, so I will do everything all at once, all the time. That's why I have 2, 3 printers, 4 if you count the bandsaw as a printer, 5 if you count the brewing setup as a printer, 6 if you count the milling machine as a... I have 6 printers in this shot. And all the parts on the right in those plastic bins, there's probably 2 more printers in those parts. I have to limit my time on eBay for the same reason. I know. I'm quitting drinking because I bought that thing. I'm serious. You guys think it's a big joke. Haha, funny. I can't spend $160 on a printer. Another one? I mean, I lucked out. This fucking thing is great. It'll be great when I get it running. I probably have to redo the print surface, which is a $40 purchase. It's not that big of a deal, but I think what I'm going to do with this one is I'm going to put it on the milling machine, flatten it out to the best of my abilities, which is not that great on this milling machine. But, you know, get rid of the laser etched surface on that, and then put one of those magnets on it with the steel plate. Because Celia Russell was saying that thing's awesome for this, because you could peel it off and clean it and do all that stuff, and then, you know, wiggle it, and then your part falls off. I think that may be the way that I'm going with this. I filled those 2 with activated carbon charcoal. That was a $25 purchase for those 2, and I probably should have just 3D printed something. I don't know if air is going to get through there. I don't know if air is going to get through there with the weak little fan that they put at the bottom of it. So I don't know if that will do a great job of filtering out scents the way that I have it set up. I may need to put like a core in it so that there's airflow. You're behind the spring steel plate too? Okay. And then I need to have a tub full of this stuff, a tub full of alcohol. And I don't know if I need to put a pump in the alcohol or not. I guess I have the 12-volt pump from Burn the Subs that we didn't use. The curing tub. And then I've got grow lights that I could put in that hood as well. Well, maybe not in the same place as the rest of it, but I've got grow lights that have a large UV component to them. They're 2 panels. They're very cheap, but 2 panels that have UV LEDs on them that I could use. I don't know about with turntable or not. Oh, I know David Mitchell. How Americans are more interested in class and income than the Brits. I can't stand it. You know, with my car buddies don't do this anymore as much. But like if you go to like a little party, like a little shindig at somebody's house, like a little barbecue, the number one question, because nobody knows what else to talk about, is what do you do for a living? What are you? How much do you make? Nobody says that explicitly. It's just that question has those layers as a part of it. Oh, I'm a lawyer. And you go, oh, you're a lawyer. You make a lot of money. You must be higher class and association than everybody else. I can't stand it. Everything everybody has to talk to because all they do is work. Work and raise kids. And I understand talking about your kids. That's totally fine. But work is like the number one conversation, and it kills me. Mostly because I don't know what the fuck to say. The barber, what do you do for a living, says the barber. And I go, and then I get like Vietnam flashbacks of all of the bullshit that I've been through making this stream work. And then the tiny little paycheck from Twitch. And I go, I do engineering stuff, you know, spreadsheets. And they go, oh, and then we don't talk about anything anymore. American culture is obsessed with work because they're squeezing every single drop out of us right now. That's just the way it seems to work. There's not a lot of hobby going around, and I think that is a fundamental flaw of the whole experience of life. Everybody needs a little bit of time to not think about stuff. Then again, I have like the number one jobby, so who am I to talk? When I did like the IED thing, reverse engineering IEDs, like that was fairly interesting for a while. But I still needed to have some kind of a creative outlet. So I was doing a lot of writing for Hackaday and like my own weird projects for festivals and things. There was just a constant drive behind doing something creative that I could take pride in and also relax while doing. So I spend money to broadcast for work. I spend money so that I look like I'm spending money. I'm a hollow shell, a husk. Yeah, so I gotta prioritize some of these things that are sitting behind me here, like all the stuff we're looking at right now. Some things, you know, like that the resin printer, I need to prove out that it's working, and I think the magnet sheet gets here today or tomorrow. And I guess the magnet sheet, you need to add washers to that Z stop, that optical stop that it has, so that it doesn't crash into the LCD. Other than that, everything seems ready to go on it. All I need to do is enclose it in something so that I don't gas out. Apparently, it, you know, that resin epoxy smell it's just ubiquitous. It gets everywhere. So if I put it inside of a little grow hood, a little Creality printer hood, it'll contain it pretty well. And I think I can do that on its side. And that way I have a little bit of room for like a tank of alcohol. I don't know if I need to make the alcohol flow to clean parts. I don't know. Can you just soak them? Or do I need to get the what is it? Ultrasonic bath? Because the ultrasonic bath I have not officially used for anything other than cleaning water cooling stuff, and I don't really think it was effective in doing that. And it's been living next to the utility sink in the other part of the basement. And I guess what I can do is remove the part from the resin printer, take it over to the bath, and throw it into the ultrasonic bath, where it would be like a bag of alcohol inside of distilled water, sitting in the in the ultrasonic cleaner, and then I guess I could run that. That would vibrate it and maybe dissolve some of the stuff. I don't know. I'll have to figure out this process. I know people have all kinds of weird cleaners where you like lower the part into a thing and it's specifically built for the resin printer. But engineering buddy of mine was talking about all the merits of resin printing. He's like, it makes a lot more sense in the way that it builds stuff. Like, well, yeah, but I can build PETG parts that I can run over with my car and they won't deform. So it's a trade-off. I like my little, you know, side desktop printer over here that I can just glance at while I'm working. I guess the tub and the lamp can live in the other part of the basement, and that way I'm not exposing any part of this printer to ultraviolet that I'm not in control of. Although the window on that hood would probably let in UV. I got a funnel with a filter on it so that I can return the resin to the bin when I'm done. And we'll have to just see where this thing benefits us. I don't know where I need high precision plastic parts. There may be some places, but I don't know. And I certainly can't do dual prints where I change to a more translucent color and then print on that. That's not really a thing that I can do, I don't think. Unless I do opaque, and then I'd have to cure the opaque and change out the resin in the tub. I don't know if that would work. Because it's not like you can go back down and zero it because you'll crush your LCD. Your part will crash into the LCD, and that would be a disaster. So like the deposit printing is much better at doing things like illuminated front screens for stuff, which I find myself doing every now and then. Certainly the resin printer will lead the way with RC car bodies, but that's almost a me project. That's not really an us project. That's almost a me project. I guess anything else that I need to pick up along the way I can do. Where did Twitch go? Where's my Twitch window? There it is. And a music window. Yes, yes. Ooh, bitrate is suffering today. Is something going on with Twitch, or maybe it's just the servers are warm from this temperature outside. It's scorching out. Hey, we got 2 YouTube viewers. I don't think I'm included in that. I got some advice that resin print would be better for the jig I'm making to melt other plastics into. For resin? What are the heat? I don't know the heat properties for resin. That's an interesting one. So like if, because I printed a PETG bracket out of black plastic for my buddy's, what are they called over here? It's a Hilux overseas, but it's like the newer one. It's a Toyota, I don't know, Tacoma, there it is. His Toyota Tacoma, he was putting one of those Android radio things, it's car computer into it. an Android head unit. There we go. He's putting an Android head unit into his Tacoma with a black interior. And so around here, you know, this isn't Arizona, but car parts, Pennsylvania roads are terrible because we see more freeze and heat cycles than any other state. It gets swampy here. It gets, I mean, we're on the same, what is it, ley line as Spain or whatever. It gets very, very nasty here. And inside of a car, you have the greenhouse environment where everything's closed and all that energy can come in and heat up your black plastic interior to astounding temperatures. You can sometimes bake cookies on the dashboard. And then next year, or sorry, in 6 months, everything's frozen over. So PETG has survived that largely. He has no reports of anything going wrong with the PETG. Now, it's inside of the dashboard, so it is covered from ultraviolet. Ultraviolet will, you know, kill the polymer strands. But in this case, it is shielded from that light. Like no light gets in because it's inside the dashboard. But the heat cycles are brutal inside of automotive electronics. And so far, so good. I haven't heard on like a super hot day if he pushes a button on his radio, if the radio like moves in a little bit. That hasn't been happening. So, have you tried rebooting your router? What? What is that? Huh? Where did that comment even come from? Oh, you're talking to nothing's working. I have better issues since buffer issues. I'm not sure if that's me or Twitch. Buffer issues are always annoying. I don't know. I've got bitrate issues, but I don't know if that's going to permeate. I think it's our normal almost 6,000 whatever bitrate. Let's see, that's my viewer count. On YouTube is entirely viewer count based, huh? Yeah, I don't know, like temperature and resin. I didn't know that would be a thing. I know the epoxy resin is exothermic, so you get this outward heat reaction on it. I don't know. It would be kind of cool if it has better temperature stability. The consumables of resin I have right here. The sheet that goes in the bed, and then the sheet that goes on to protect the LCD. This one I'm probably not going to have to replace, which is a shame because it was a pack of like 5. And then this one I may. But I'll probably have to do this one again because there was a tiny little speck of something on one part of the LCD. So if it ever comes to the fact, like if I ever need the whole bed, I'm going to have to go back and redo these because there's a tiny, tiny little speck on it, which is very annoying. I don't know where to store all this stuff, too. I need my own filing cabinet for these things. Maybe that's where the point of sale... I can use that as... Yeah, keep that under the printer and use it as a little... And then every time I need, like, consumables, it goes cha-ching and pops open. I have a feeling there won't be airflow through the carbon fiber, or through the activated carbon, because I put powder in there, and it's very dense powder. I think I need to get much looser powder. This stuff was meant for aquariums, so I don't think it's really going to do anything in terms of filtering. I mean, can we test that right now? We could test that. Let's do a quick little test. I got a lighter. So there's 2 little USB slots on either side of the resin printer. Might try again later. Switching to UDM, what's that? This is the one that came with the printer. It's all kinds of busted up, and it's got all kinds of bullshit all over it. What sits inside of this chamber is this Arnold Schwarzenegger style bazooka of square tubes. You can see that there. So air passes through this without touching it. For a large part. I guess multiple cycles would be necessary, but it seems as though we're not taking a meandering path. And this barely fits inside of there, so all the air goes around it. I guess it is passing the carbon, so there's a potential for stuff to happen there, but what I did is I decided to fill it because I'm a cheapskate and I've already got aquarium parts sitting around, I filled it with this kind of stuff. He's like a salt shaker. These little guys probably will seal around that, though, a lot better. And there's also a piece of carbon foam at the bottom here to keep the little bits from getting into the fan. Because there's just a little 40mm fan at the bottom of this thing. Yeah. You guys have carbon at this table? I feel the need to deactivate some poisons that I had earlier. Do you guys have carbon maybe that I could shake over my food? Yeah, let's get start soon out of there. We'll do VCO repair in just a little bit. I just want to test this theory and see how shitty it is. I want to see the air not passing through the carbon. So the two little towers that look like this sit at the back of the resin printer and supposedly remove some of that horrible smell, the headache-causing smell that gets into the air when you print with resin. I don't know about the efficacy of either of the systems, the one where I put powder in it or the one where I have the block of stuff passing through. It seems like maybe I need a more serious filter for that space, but I don't know, I could just try it for right now. Are you building basically a catalytic converter for the printer? If I just plug this right in, then it will be powered off of this socket right here. There's the green light. So is there any airflow? Somebody said there was noise from it, but I don't hear a damn thing. We should maybe see that the propeller is actually working on this thing. So here's what I did. I put a piece of foam in there to protect the fan. Little bits will probably still get down into the fan. But if I plug this in, that's not moving. The light's on, but this thing isn't blowing at all. Wait. Why are you not turning on? Did I miss something? What? Huh? Does it have to get like a go-ahead from the printer? Or are they using it as a USB socket but not as actual USB? There's something else about the socket that I need to power up in order to get the fan running. I'll bet you that's it. I'll bet you they're using the data pins as a power, like an activator. Now I need to get into one of these. Let's pull this one apart. Wow, this one is in bad shape. It's like the socket is green. It still lights up. So let's see about getting into the one that's terrible. We'll just see how this thing is done. It's probably snapped together. So I gotta carefully move this thing because it's essentially a salt shaker. It's gonna leave carbon everywhere. I don't actually think that air is gonna get through there. Let's test it real quick. All right. So is it? Well, it is glued together, but is it glued together from the factory? Probably not. I think I can get a screwdriver in there. Yeah, what are we doing today? Well, I would like to get some VCOs working. The synthesizer stuff is killing me. Julian even texted me today. He was looking for advice on teaching high schoolers electrical engineering. I guess he's got a student who's interested in EE. And I told him it's been 30 years since I started in EE, but I would ask my peoples if they had any good suggestion. So if you guys have anything that you think would help a teenager start out in electrical engineering, I was told, I don't know if specifically electronics or what, hop on the Discord, because we would love to hear about it. Love to hear about it. Because it's been, I started out, I did it, but I'm not doing that anymore. I already have all the knowledge. I'm going to try crushing this just because I think this is I don't know if it's plastic welded, but it does seem as though there's some kind of a snap action going on here that no, can't do that. So what do? We attack the corners. Well, this is the only in that I've got is right here between the two materials. And if I continue to harass this, well, it'll just open up. Looks like there's the side of the fan, and then below it's a little circuit board. Is this snapped in, or it's plastic welded? How cheap. How cheap of you to plastic weld, I say. getting my pliers of breaking. All right, that didn't work. Plastic welding. All right, there's fan. The other part of this is that there's been resin leaking into this thing for a time. So if these aren't glued together, they sure are now. Ooh, that yak has a little bit of hair on it still. Have to deal. One day I'm going to pull the pin out of this thing. I'm using it as something to grip at a right angle. I probably shouldn't use it like that. Just grab it and pull. Oh, there we go. Well, what the heck? Why wouldn't the fan turn on then? Because all this is 2 plugs and an LED. So all this is doing is getting power and ground and then turning on the fan. But the fan wouldn't turn on. There's the plug. There's the PCB. And it's got a broken LED. I broke the LED. And all it is plus and minus. And there's a resistor for the LED. There's nothing else on the circuit board. Check it out. I'm letting the LEGO out. Yeah, exactly. +1 to breaking stuff. Pliers. Yeah, there's nothing to the circuit board. So why wasn't the fan running on either one? What voltage are we at? It should be 5 volt. What the f... Okay, word of advice. Anybody buying an LEGO 3D printer, do not plug any USB into those internal bed USB plugs. It is 24 volts. That is incredibly irresponsible of them. USB socket here is being used as just a plug, which is an incredibly irresponsible thing to do. They're putting 24 volts into this, which goes to this, and then it goes directly to the fan. So if you plug this fan into a 5 volts USB socket, nothing happens. But if you plug a USB device into your LEGO 3D printer bed USB, thinking that it will power, for instance, a low voltage DC fan, it'll put 24 volts into your fan without a single shred of remorse. And you will blow stuff up and not be happy. I should know, I'm never happy. I have all kinds of USB sockets. I think I have a USB socket that we can throw 24 volts in for a time. In fact, it's right here. And it's got headers sticking off of it. That's really annoying. I can't believe they would do that. That's like really irresponsible. It's not good. I mean, they make a fine printer, but 24 volts into a 5 volt socket, or a universally understood as 5 volt socket, is not a good scene. If this thing has a status LED on it, rest in peace. Let's see, 5 volts, haha, as if. 5 volts, and then ground is the second one on this. That pin's bent. Bend that back. Ugh, and of course, these easy clip leads are so obnoxious. They slip off of everything. They're terrible. I mean, you can kind of bend some of them down, but then they become a little less useful. But like when you have them like this, they just slip. All right, turn on my power supply. Let's see what we got here. Fine printer, read the fine print. I hope that there's fine print. I think there's a sign on the plug itself. I think it does have a sign on it. So here it is at 5 volts. LED is on, but barely. And this would actually be a good level for a status indicator LED, which is 1/5 of the voltage that it should get. So this thing is going to be obnoxiously bright. Turn the voltage up to 6 volts. Oh, wait. Voltage 6 volts. 7 volts. No fan movement. 8, 9. This is 9 volts. I'm hearing a noise from the fan. It's like a screaming noise. 10. 11. We've got movement on the fan. 12. 13. 14. Look for any heat anywhere that it shouldn't be. No, it looks like we're okay. Fans moving. 15. 16. 17. Any heat? 19, 20, 21, 22, 23, 24 volts. 24 volts. Fans moving. I think. That shit is not moving air. I don't feel any airflow at all, even though the fan is in fact moving. What direction is it moving in? I think it's probably going this way. Yeah. Yeah, with the plug at the bottom, it's moving air down through everything. So the question is, can this thing actually work for my through this giant block of very thin very small carbon? It seems like it probably needs a larger piece of carbon on it. I mean, if there wasn't any airflow before, it's certainly not clocking any airflow now. And I have a feeling that it won't even pull. Oh, I hear. Yeah, I hear stuff going through the fan. I hear little grits going down. It is not a powerful fan. I don't know if I need to reinvent this one. Put this thing on its side. We will see sparks, by the way, if I accidentally short any of this. So if I light a piece of paper on fire and put it right here, what the hell is going to happen? Well, actually, what's happened is the carbon in this thing is settled like that. So it might actually provide it with some filtration. We're giving it every advantage, aren't we? Paper. I have paper somewhere. A little piece of paper towel. I have a feeling absolutely nothing is going to come of this, but we might as well test it once. Just make a little incense here. And the ever-present torch. That didn't work. There you go. Get a little tiny wisp of smoke out the end here. Oh, I need to move the fan that's on my back. I always have a fan on me in the shop, so I need to move that because it's actually moving a lot more air. So we can't actually see smoke wisping up from the end of this thing. Now this fan is going back here. I just need to get this to start making smoke. Get a little ember going on the end. Ain't doing shit. That ain't doing shit. Nothing. All right, so that theory's out. That theory is out. What about back here? Uh-huh. 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 Nothing. None of it's doing anything. All right, so my own method of putting a little bit of activated charcoal in there does nothing. I guess I wonder if the doing the original carbon in there would actually do something, because if it's constantly cycling the air inside the chamber around, it's possible that it would pass it enough times that it would do something. Strap another fan to the top to make it push-pull. Well, it would reduce the pressure and maybe it would move. But this is aquarium carbon, so I think my experiment is failed. All right, well, now we know. I don't know if the other piece of carbon will do anything, though, because you can see through the whole thing. You can see right through it. It's just a chunk of carbon that you know, maybe a couple molecules of air happen to pass into. I would feel better if it was a solid chunk of activated carbon foam. But you have to be careful about what foam you get, because I saw on some of the Voron printer stuff, they explain how some of those activated carbons can produce something that will rust all the stuff inside of your printer. So I guess aquarium carbon is out. It's too small. I'll have to clean that one up after stream. Now it smells like burning paper in here, because I burnt paper in here. You reap what you sow, maker. All right, so now I got to clean all this stuff off. We got to do synthesizer stuff, because I got what this right here is the package of the remaining part that we have to replace when the the M303 gets overpowered or plugged in wrong. And I guess tomorrow what I'll do is I'll clean out that area for the printer, and maybe I'll have something to show for that. I need to print out like a benchy. What do you do on these resin printers? What do you print? You print benchy? I guess so. Benchy's pretty universal. This stuff's going in the garbage. Never to be used. Well, now I know that those USB slots are 24 volts, just in case I feel like building my own type of respirator for that thing. I also have the car filter, that like external car filter that I could put on the fume hood if I need it, on the like grow tent. And so that could also be a good air filter. Yeah, that if I ever need to blow up a memory stick, you know, like these files, this data will self-destruct. Please plug it into your resin printer and then turn it on. I can't believe they're only 24 volts to those things. Damn. All right, let's get a synthesizer like actually functioning. Hopefully we can do that, and I didn't blow it up with my own shenanigans, because my own shenanigans took us in a direction where I gave things voltage that really shouldn't have gotten voltage. They really shouldn't have. I plugged in the front panel wrong, and I hope I didn't do permanent damage to the thing. But if you guys are unfamiliar, which there's like 5 of you right now, nobody's here. You guys should all be very familiar with all the projects that I'm working on, but this is Dave's M303. Dave and Julian are a pair of crazy people that I know, and I've known since high school, a million years ago. And Julian, for one, has been after me for 20 plus years to build a synthesizer. Now, I've lived in the world of digital electronics and soldering, and I know those things fairly well. The analog stuff that I do is usually in service of some kind of a digital task. That's where a lot of the fun is. You can stay in digital and things are nice and easy and low voltage, and you don't have to deal with a lot of the real world factors that kind of get in there and a lot of the messy equations. But inevitably everything leads back to analog in the end. So what we've got here is part of my foyer into getting better with analog circuits. Now the M303, the TB303 is actually the parent to this module. If you don't know modular synthesizers, what they've done is they've taken all the tasks that a synthesizer typically does and have split it out into different modules so that you have this walled garden where you cannot do no wrong, and you just plug stuff into stuff, and eventually you get cool noises out the other end. That's as boiled down as I could possibly make it. So you can plug anything into anything, and anything will do anything, and anything will do anything to anything, and sometimes anything comes out the other end. Typically, sound. Cool thing. Miniatures for war games is a huge... Yeah, all of the documentation for resin printers, it's all man-baby toys. All of it. The whole thing about resin printers, man-baby toys. I don't do man-baby toys. I don't. I just don't. Maybe I'll print a couple just for fun. Some dildonics or something like that. I don't know. But I don't do bearded man-baby on the internet. Overweight, bearded, angry guy on the internet. Oh, shit. Well, I don't mean to. I don't mean to do bearded man baby stuff on the internet. But here we are. I'm hoping that it comes in handy for some engineering stuff, and I think my friend was very positive about it being a kind of a nice thing to have. So maybe if we get to some more complicated, like, I don't know, electronics enclosures and stuff, I think the CNC will probably do me a lot better, though, because then I'll be able to cut carbon fiber plates into synthesizer module covers. Anyway, the TB303 is a legendary acid house synthesizer sequencer. But TB303, funny form factor. What if somebody, acidlabs.de, made one and put it into a modular synthesizer package? And what if they also put some of those signature filters and they made it into what's called a VCO, a voltage controlled oscillator? So all the sequencing stuff, some of the control stuff, throw it in the garbage. You can use other stuff to do that. To make that signature 303 sound, why don't we put the voltage controlled oscillator and the signature filter all in one module? And that's what the M303 is. So it's a TB303, but without all of the extra stuff that you don't need in modular synthesizers, because you have other modules doing that stuff. Acid Labs, for all intents and purposes, did a really good job replicating the sound of modern electronics. When you get into stuff like modular synthesizers and you get into kind of the fringes of electronics, you start to discover things aren't always supported. It's sort of the same mentality that we ran into with the internet. We thought that everything you ever did on the internet would be around forever, always. That tends to not be true, and we've learned that. You know, a lot of Flash games are gone. A lot of old web pages go away. The Wayback Machine doesn't catch everything. And so, and the Wayback Machine might not last forever. So same thing goes with electronics. A lot of the sounds that we heard in the early 90s are no longer around. They don't exist anymore because the chips, the ASICs, have gone out of production. You can still sometimes find new old stock, but it's very difficult. And other times, the person who invented the chip and distributed it died. And that's what happened with a couple of the like X4046 VCO modules and stuff like that. These were like through-hole chips that would perform the task of a VCO just in one chip. And you were able to put some support electronics around it, and it would work in a modular synthesizer or just a normal synthesizer, but that guy died. And so his widow eventually said, you know what, it's okay if you guys reproduce this chip. And so people started to reproduce the chip finally. We were able to get it back and get that signature sound back. So the same thing goes for the TB303. I mean, this is Roland doing the TB303, so they're proprietary designs, but the electronics have been, they're gone. Like some of the stuff you just can't find anymore. So what Acid Labs have done is they've spent their own time and resources putting together a circuit that works for that kind of stuff. This is really fisheye. I think the camera set itself back to 90 degrees because these are straight lines. These aren't, they look like they're like concave. The board is not concave, I can assure you of that. And if I move it closer to the fisheye, it's going to be convex. Ugh, disturbing. But anyway, all that's said and done. Said and done. They decided to use a completely unkeyed IDC connector on the back. IDC is insulation displacement connector. IDCs just basically have these little vampire clips that squish over a flat cable. So they're your typical flat cable connector, which is very useful in consumer electronics of yesteryear. Nowadays, everything is one of those printed circuit board cables, which we're now only just be able to produce. We can actually work with those now. But in the past, it was like this or nothing, right? You worked with this cable. And so a lot of products have this kind of stuff in it. It takes up a lot of space, but it's good. With modular synthesizers, you have a typical plug that this will plug into, and it is a keyed plug, and it has power and ground and negative voltage all on particular rails. What Acid Labs has is also a bus line rail that you can plug in between their products, and it's their own proprietary thing. So they only included that. But as a caveat, you can plug in your IDC cable so long as this pin right here, the one with the stripe on it, goes to the -12 rail. And the -12 rail is at the bottom of this connector. This connector is a special connector where if you plug it in the middle, the ends are in little troughs that don't have a connection. It is the most evil cable ever to be invented by mankind. So those pins have this little opening that they can go into. If you plug in the Acid Labs proprietary plug, it is 2 pins wider. It is not this type of plug. The reason this type of plug is included is because the way to plug this in is like this. This is how you're supposed to plug it in. Completely counterintuitive. You have to know, it's like an IKYK, if you know, you know. So this is how you're supposed to plug it in. And if you don't plug it in that way, you destroy this chip, this resistor, this transistor. I don't think its buddy is destroyed, and I think a diode, and then this chip right here. They're all highlighted in a document for this thing. Yeah, it really is very evil. Oh, it doesn't have a sequencer. Oh, that's the drum machine then that I'm thinking of. I'm more familiar with the drum machine. Yeah, so it's more of a synth voice module. Okay, well then it makes even more sense to turn into a VCO, right? Do we have that anymore? Do I have the document anymore? No, because we did a bunch of programming stuff and then I closed it. It was Ben Gizmo works, a user on Twitch, Ben Gizmo, knows about this stuff and knows that there is a PDF document that they've released because they got sick of answering the question, my thingy exploded, what chips do I need to replace? I mean, at least they released a document, but I really think that they should put a keyed connector on the fucking thing. I think they should have spent the time in the engineering effort to put another connector on it because I don't think it would have been too much of a burden. It would have been a burden. It would have been tough to do. But there are some areas of this circuit board that are not populated very densely. And so I think it would stand to reason in areas like up here or maybe just right next to, instead of having the jumpers here, you put the jumpers somewhere else. But I mean, maybe right here, you could put a keyed connector and spend an extra $2 on connectors, probably 50 cents per board, and maybe just eat that cost. And then you would have an listen, I know 2 people with modular synthesizers, and I've had to fix a handful of devices with keyed connectors that have been plugged in backwards. I've had to rescue these devices. 2 diodes and a keyed connector. That's it. 2 diodes, keyed connector. Should be required. Should be part of the standard. So not having this type of equipment, yeah. And the other part of it is that Dave has come to me at a time when I am just simply getting refamiliar with how to test analog electronics. We have a picture of both sides of this board. It was our last-ditch effort to try to repair it until Ben Gizmo told me that there was a document with commonly repaired parts. We've been trying to get to the bottom of this for quite some time. I tried to put IDC cables on these 2 connectors going to the front panel. I think I got them backwards. There's a chance that I broke something else. But we have a picture with both sides of the traces. Most of the components identified. There's still one mystery IC, I believe. They sanded off the IDs on all the ICs. So we were unable to look up a lot of them, even though they're very common. One of them was even sanded off and was identified in the replacement parts document. So there's yeah, very annoying. Somewhat evil. Oh, the Roland one has one. Oh, the modules do. Yeah, this doesn't have the sequencer on it. The Roland one does. Okay, I didn't know. Yeah, the Roland, the 303 and the 505 and the TB or TR. I know the 505 very well. I know of the 303. I didn't know there was a different drum module and synth module. I think the 505 is the reason why Futurama has a 1, 2, 3 sound in it. Anyway, yeah, so what we're doing is we are replacing the very final IC, which took a little bit to get to me. And we're going to see if this thing works. And it probably won't. I'm going to say that right now because I probably screwed it up. Because when electronics get hot, when you plug stuff in the way it ain't supposed to be plugged in, you do not get much forgiveness. In fact, you don't get any. You get 0 forgiveness. I remember that was one of the first things somebody told me about electronics. Was a friend of mine in grade school when we were little kids, and he was saying we did an electronics project in this like, I don't know, summer camp that I went to, and we made a thing that follows a line along the ground. And it was so cool because if you're lucky, you get a little warning. If you're lucky, things will heat up and you go, ah, and you turn it off just fast enough that it doesn't, blow up your parts. But typically, no. Typically, you screw up and that's it. Oh, wait, hold on. I'm screwing up. I got to plug this connector into the middle so that we can pinch this like that. And then I will be able to hold the circuit board steady and above the desk. And we can use things like hot air and solder on this. We'll probably use solder. And then I got to figure out what direction this thing was facing. I think I lost the link to that PDF, though. Was it Acid Labs? That's a Mod Wiggler. Eurorack module, Mod Wiggler. I don't know if I'm going to be able to find that PDF again unless Bing Gizmo suddenly shows up and links it again. Because that's just going to be the topic. And then there's Power Rails, but this one doesn't get into it. Acid Labs, replace parts, M303. PDF. That's the manual. That's not what I'm looking for. Milk Audio Store. Ugh. Let's see. Can I get like a picture of the PDF? It was something from like the main engineer. Did you mean Acid Labs replacement parts M303? No. Yeah, it was a pretty special thing, which is why I decided that we would mess with it. All right, well we have our picture. I have a picture in GIMP. Oh yeah, this is Node-RED and Linux hell. Am I allowed to say hell on a title card for a YouTube video? I guess I'll find out. Yeah, I could do the who is it? Whatever, the bot saves chat messages, but that's okay. I've got the picture here, open recent. And then we're looking at, I have too many. Okay, so we'll have to just go open and I'll have to find the image. It'll be in our project section, stream section, and then synth, QRS. Very well documented. If I was doing this professionally, I would be taking pictures of goddamn everything that I see if I'm repairing stuff like this. This would be M303. What did I call that folder? I may have accidentally put it in a different crimes, peaks. That's weird. Where did I put it? Is it in the root directory and I'm just not seeing it? Where's XCF? Nope. Is M303 a folder here? No. Oh, you know what? It might be on the desktop. Because I couldn't get into the folder. Yeah, there it is. It's on the desktop because I couldn't get this program to play along with directories properly. So what we're replacing is a Schottky hex inverter, isn't it? It's like and it goes this blank spot here. 3 mares resubbing for 68 months. It's the world famous 3 mares. Hey, thank you for 68 months. Holy crap. It is. The numbers are getting larger, and it's kind of scary. That is a very large number. Let's not worry about that. Just celebrate it. Thank you so much for that much time and dedication. Oh, there it is. This is the one we're replacing. What does it do? I don't know. I have the capacity to know what it does if I figure out what all the different connections in the circuit board are. But that looks a lot like work. It's a lot of stuff to worry about. What's nearby? I think this is the one. It's a, I don't know if it's a 14106. We have, the Ben Gizmo document is somewhere. Yeah, the sands of time. The sands of time go marching on. So this is some kind of a Schottky inverting thingamajig, right? We can figure out what it does. Let's look up 14106, because I don't think that's the right part. I think that's what we thought it was before, and we were not correct about. Oops, sorry. Oh, no, I don't need a new research window. There it is, this one. 14106. Oh, this is the right part. Okay, so a hex Schmidt trigger. Think about electronics and ones and zeros is when you have a system that runs off of ones and zeros, 1 and 0 is not enough. You have to have a range of voltage values that you will count as 1, or a range of voltage values that you will count as 0. And those are, you know, a band of voltages that you will accept. If you take that as rigidly as possible, that creates some problems. Because sometimes when you're going from a 0 to a 1, you will be at an interim voltage level for a little bit too long, or maybe there's a slight overlap, and you're going to be at that sort of unknown territory for too long. So your 1, 0, 1 can be a 1, 1, 0, 1, 0, 0, 0, 1, and then 1, 1, 1, 1, 1, 1 afterwards. And so that can cause a lot of turmoil within your electronics. You can cause chattering, you can cause things to recognize something as an address when it's not. There's all kinds of problems that can happen there. So what you do is you define a gray area. And so every time the voltage goes below this value, it is a 0. Every time it goes above this value, it is a 1. But in that interstitial area, it'll stick to where it was. And that way you get more definitive triggers. So what this does is this does that Schmidt triggering. It also inverts the signal, I believe. Or no, it says Schmidt trigger, so it doesn't invert. Well, it does invert because there's a little hoop around the end of the triangle. When there's a little hoop around the end of the triangle, it means it's the opposite of what it was. So your ones are zeros, your zeros are ones. So yeah, the arrow there is just a unity gain amplifier. So a 1 coming in is a 1 going out. And even in the digital world, that's just what that means. It just means it's just isolating and moving your 1 over to the next stage. When there's a little hoop on it, that means that it turns your 1 into a 0 and your 0 into a 1. So we have this in here in order to prevent, I suppose, chattering of some sort. So that's neat. Internally, what this thing looks like is just a bunch of triggers that are inside of a little bug thing, right? You get a little bug thing, and then according to the pin numbers, you have triggers betwixt them, and we don't really need to know anything else about it. We just need to know those ins and outs. I mean, as electrical engineers, we need to know when it's going to blow up, you know, what kind of voltages we can put through it and stuff like that. But I mean, one of the more important parts is just the pinout. I don't like that. I wish they drew the little box with the little triggers inside of them. But it goes from pin 1 to pin 2. And since chips are a subset, they evolved from vacuum tubes. It means we go anti-clockwise around the circle from the gap, which is the 0 mark, the pin number 1 mark. So we do not zero index when we count pins. These are pin numbers, and pin 0 is a nonsensical thing. So we have pin 1, 2, 3, 4, 5, 6, 7, and then we go to the other side of the chip because we're going anti-clockwise. Same thing with, you know, these dip packages here. When you get into QFNs, there's the pin 1 marking on it still, and you go anti-clockwise around the whole thing. Vacuum tubes, you have a gap in the pins, and then they go, you know, anti-clockwise around the circle. That's just where it came from. That's just where the numbering comes from. Now, when it gets to connectors, that's when you go 1, 2, 3, 4, 5. You go on a zigzag down the connector. It is intended to be as confusing as possible. So we now know what our chip looks like. We know how it functions. Where's the pin 1 marking on this thing? It looks like it's over here. They sanded off, so we work in layers on this thing. They sanded off the markings, and whatever chip that they sourced didn't have that little circle to denote where pin 1 is. But we have a little angle cut. We have a chamfer and fillet. We have a fillet on the edge. So that fillet tells us what the first bank of pins is. And the first banks of pins is on this pin 1. So yeah, pin 1 is facing on the 2 diode side of the chip. It's the 2 diode side of the chip, pin 1 downwards, and it connects to pin 3. Why does it do that? That's a weird connection. Pin 1 and pin 3, what does that get it? That's like the output of 2 different... That better go somewhere else. If that just goes to pin 1 to pin 3, because pin 1 and pin 3 are outputs, from what I understand. I may have to just extracurricularly reverse engineer this. Oh, they're both inputs, so we are broadcasting something? It wouldn't be like, you wouldn't connect pin 1 and pin 3 without something else being connected. I think that's a via right there. Let's just check what my notes say. Boop, boop. Yeah, okay. But those connect to ground? Wait, what? Huh? Why would you do that? Wait a minute, why would you do that? 1 and 3 are connected to ground. That doesn't make any sense. Is that really what this thing is? Well, let's look up the chip that I bought, because I know the one I bought is correct. And I'll make a note of what it is when on the document, because that's my only documentation until I track down Ben Gizmo and get another link to that PDF, which I probably noted down somewhere. I probably have it in some kind of documentation. I just didn't think I'd need it. Plorp. What do we just plorp down? Hard to see. CD 401068. Okay, that's the same chip. It's the same chip, different manufacturer. Or no, it's not. 401. This is 141. Okay, CD 401068. CD 401068. CD 401. Bah! 401068. Hex-Schmidt trigger inverter. It's the same thing. Let's pin out. And that was a pinout. Was that the pinout? Was that the only one we get? Oh my god, we get to see what the chip looks like. Oh my god, it's so meaningful. Ugh. Okay, all the way back up here. Okay, so yeah, it is 1, 2, 3. So that would be input A and B would be going to ground. Very strange. And that is, well, that's the chip I bought, and I believe it's the chip that they call for in the circuit. It was in that repair document, so I guess that's what it is. I don't know why you would ground the inputs to 2 Schmidt triggers. Maybe if they're not in use, you want to just ground them so they're stable and they don't mess up the rest of the chip with like noise. Let's look again. That would mean that, oh yeah, see, this pin and this pin are floating. Okay, all right. So they're not used. My whole like confusion there is just because they're doing their due diligence and they're grounding out pins that they're not using. So all right, never mind. So those go to float. Those are always going to be at a 1, but it's not really going to matter that much. This old chip is good up to 18 volts too. Where's that one go? Might go across. Why would it be? All right, let's take a look over here. Let's get this new chip in and let's see if that repairs our whole thing. I could use hot air to put this thing all in one go. I don't think that's really going to be a good use of any of our time. I don't think that's really going to go in like. How do I explain this? It's just too much trouble, right? God bless All Datasheet. All Datasheet can be very helpful, but it can also be very annoying because you get sort of an oversaturation. Hey, your stupid TTYRS 485. What is that? It's very specific. It's very, very specific, and you're very mad. glad you got it out. All right, so we're gonna put this chip in. The soldering iron's already hot. This thing heats up in like a second. I gotta get solder. And then we're gonna anchor this with one pin and then solder the rest. I'm probably gonna go by hand. I don't need to drag solder. I don't need to hot air solder or any of that stuff. Hot air runs the risk of melting stuff around it and potentially like rearranging your boogers. So I don't really want to do that. It is very easy though when you get used to hot air solder. Really? It can take up to 18 volts, but if you get it like if you just mention static electricity, it'll die. Yeah, there was a lot of people were very concerned about static electricity and electronics, and I never really was. I've never really had static electricity issues. I just have friends who power up their devices wrong issue. When you static electricity shock a piece of electronics, you got to know that your electronics are a die, as in D-I-E, not D-Y-E. You might think D-Y-E because it is a printed circuit, but it is D-I-E because it is a dielectric. So you have a die sitting on an epoxy substrate with metal pins surrounding it, but not touching it. Those metal pins are then bonded to the die using tiny little gold wires, and these tiny little gold wires are pressed down. And when you press down gold wire on a very small scale, it crushes. It crushes into a little boobel, and that little boobel at the very interface, the microscopic interface between the boobel and the metal, or the boobel and the dielectric, creates a cold weld. And so that cold weld carries your current into your chip. If you static electricity your chip, that little interface, that little cold weld, takes a brutal beating and can wear away. And so eventually, the more you static electricity your stuff, the more it'll wear away. And there's a limit. Once you get to that limit, it no longer works. So older, sensitive electronics, that bond, that interface, call it, it wears away much more easily. All statistical probabilities, but I guess they've had better ways to do stuff now, and possibly mitigation of static electricity. Most of what you try to do is you try to give that static electricity a nice big ground plane that it can follow to fruition. You say, if you need to leave, there is a quick exit for you over there. You don't need to go through all the sensitive parts of the electronics. And so it'll tend to go through that more than the other parts of your electronics. But the rest of your electronics is still subject to it, just to a lesser extent. This is like not, why is this not happening? What's going on here? Yeah, the problem is the static electricity machine, and I'm familiar with the static electricity machine. It's not as effective as actual static electricity. It's there for testing of consumer products, and you need to have the right conditions in order to use it. We had one at an old job of mine where I did actual audio engineering stuff with consumer products. And eventually you put the device in a room isolated, and you set up the static discharge machine on a tripod, and you hit it like 5,000 times with a static shock to see if it's doing stuff right. But nowadays, there are components and sort of internal structures and things like that that they do in order to help mitigate static. So electronics are far less frustrating to work with. As long as you touch the case a lot. If you're working on carpet and you're building a computer, touch the case of your computer. Or, well, actually not the case, touch the case of something else. Because your computer shouldn't be plugged into the wall. And the wall is what has a nice big ground wire. Touch the doorknob, touch your friend, you know, whatever gets you to where you need to be to build that computer. Like a big metal desk or something that's grounded. All right, so that's my terrible soldering job. This thing is all the way cocked over to one side, but it should be enough that everything gets the connection, and we can see whether or not we can get this thing running. There might be more that's broken to it. I'm tempering my expectations. he created a device. Even still, I don't think you're going to get quite there, unless he created a Van de Graaff generator, in which case a Van de Graaff generator is literally rubbing your socks on the carpet, only the carpet's on a conveyor belt. So Van de Graaff generator will create you some pretty mean static shocks. That's what happened with my iPhone. Well, actually, my regular phone's like that too. I used to never drop phones until I started keeping it in my shirt pocket. No, I used to just never drop phones. I would never drop a phone. That was unthinkable. But then I dropped it a couple times. And yeah, the consequences were that now my screen is permanently shattered. And I can't lord it over people who have dropped their phones. That's the worst part about dropping your phone, is you can no longer say, I never dropped my phone. You can no longer be smug. All right, so how are we testing this thing? Well, we need to power it up and make sure that it doesn't explode. That's number one. Number two, it needs to be creating an output. It needs to be creating at all times a control voltage based VCO output. Now, we've replaced a lot of electronics in this thing. These potentiometers might need to be tuned in order to get this thing to output properly. I'm not sure about that, and so we might be struggling with it for a little bit. I don't have the test regimen that they put this thing through. So let's make sure we're plugged into power properly. Stripe all the way at the bottom of the second connector. And it has to go to the first row of actual pins and not the little cheaty extra pins in there. This is a type of cable, IDC cable, that's designed so that you can plug it in anywhere in the IDC. Dangerous. It's a very dangerous cable to have, especially if you don't have any labels on the bottom of your circuit board. And there's a nice spot where you could put a nice little label that maybe points to where the stripe goes. You could put a little label right there, but there's no labels on this thing. You have to go on forums in order to figure out how to hook it up. With modular synthesizers, it's the, I don't know if you want to call it a row or a column, I forget which way you call that, but it's a 5x2 connector, and the pins 1 and 2, pins 3, 4, 5, those are connected in they're connected in banks. So 1 and 2 are negative. 3, 4, 5, 6, 7, 8 are ground. 9 and 10 are power. And this is a 14-pin connector because it's a little bit of a weirdo, but you have control voltages on the next two. Well, you have 5 volts on the next bank, and then you have control voltage of some kind on the one after that. You don't have to worry about those. Typically with a modular synthesizer, everybody decided on everything, and so everything is completely crazy. But with power, purely power, everybody figures, well, a lot of electronics are digital, a lot of the analog stuff doesn't need that much current. Let's just run everything off of 12 volts ground and negative 12 volts, and that way we can have all of our positive and negative voltages. Everybody gets all the power they need, and we get rid of all that backrooms complexity about the whole thing. So that's what modular synthesizers have sort of decided on for the most part, but you know, everything's crazy. Some people do things the way, crazy kooky ways that they want to. I like sticking to the 10-pin connector and then just keeping it as minimalist as possible. Don't even need 5 volts. And if a synthesizer producer wants to be wacky, I throw it in the garbage. There's a VCO attached to the VCF in this one. I don't think I need a trigger in order to run it. We'll have to check on that, but I don't think I do. I could be wrong. So I need plus, minus, and ground. Now, voltages are all relative. If you don't have a positive and negative power supply, it all depends on how you plug in the power supplies you have. There's sometimes a little bit of weirdness, but if you have 2 isolated power supplies and they're both 12 volts, you hook up positive 12 to ground, and then that positive 12 to ground line is your ground. You are naming that as your ground. And so below that is your minus 12, and above that is your plus 12. So you may have a pin that's labeled ground that is actually your negative 12. That's how that works. If you have a power supply that says it's negative 12 volts, what? What, huh? It's all relative. It's all potentials. Right, it has a VCO out. I mean, that's what, out. VCF in, VCO CV, CV in, slide in. Is that how it does a slide whistle? Okay, so grab this. Now this is my Agilent, my super duper Agilent power supply. This thing does positive and negative voltages in one package. So this is what I use in order to test things like this. And then I also bought BNC to 1/8" stereo jacks, which are amazing. So I can plug directly into the oscilloscope. Actually, I should hit the power button on this because this thing takes... Are we doing the bit again? Can we tolerate doing the bit? It takes too long. This takes a full minute. It's like 57 seconds or something to go from pressing the power button to actually turning on. It's not all that complicated of a system, but it is Android based, and I guess it just takes its sweet, sweet time. I've never seen an oscope take this long. Ah, sorry. Okay. And then, let's see, we got this over here, we got my jumpers over here. The Agilent power supply, the big shortfall of it is that you need to actually turn power on in order to adjust to the voltages. I dislike that feature quite a lot. So I have to turn it on, turn the output on, then go to plus 25, give that 12 volts. Go to minus 25, give that 12 volts. Turn it off. If I were testing a module from the very beginning and I didn't want things to explode theatrically, which is typically what I like to have happen because I'm on camera, I know I should have a little bit where I do elevator music while we wait for the thing to start up. For me, stuff exploding is a way to go viral, and I don't ever want to force it. I don't ever want to look like I'm trying to make things explode. But for you, you may not want to blow up a rare and expensive synthesizer module or whatever you're trying to test, something you've worked on for hours. The way to do it is these power supplies. Any power supply that's worth its salt allows you to limit the current. So you can limit it to 100 millivolts. If your circuit is rated for amps, you can do like 100 millivolts. Or if it's rated for millivolts, you can do tens of millivolts or 5 millivolts. You can try a lower current so that it doesn't harm things at first, and then you sneak your voltage up to the voltage level, and then if that's not heating up anything or blowing anything up, and it may draw maximum current, you sneak up that current, and you'll eventually get to a point where you know whether or not it's shorting out. So it's, you know, just one way to test your circuits initially before having it blow up at you. The problem is if you sneak up that voltage, sometimes you can power up different facets of a circuit that you don't want to have powered up. So I mean, current limiting is a big way to do it. That initial thing that I do is I go to full voltage. It's not what you should do. I go to full voltage, power it up, look at the current, and if it's excessive, turn it off, and then I look at the thermal camera to see what heated up. That's how the streamer does it. Don't do what the streamer does. It's a dangerous way to do things. Now I did the black wire as ground. I did the typical red wire that I use as positive, which is this yellow wire. I usually like using yellow for positive 12. And then the new one, the weirdo alligatory clampy one, is hooked up to that minus rail over there. So that one goes here. Now we have power hooked up. Our output is off. We've got all the new chips in there. I'm tempted to power it up without the front piece on, just so we can see if something heats up. Although I have a feeling stuff will heat up anyway. Yeah, good power supply, knowing what you're doing is going to be the best thing. First electronics physics class blowing things up. Well, back in the day, they had us just plug a transformer into the wall and turn that on. I think that was to weed out all the unlucky kids, because the unlucky kids would die, and then the only ones left would be the lucky ones. I'm going to power it on like this, and I'm going to look at heat, but it's not going to function. We know it's not going to function because I don't have any of the potentiometers on the thing. That's the typical stuff that heats up there. That one always seems to heat up. Does it heat up excessively? It just seems to be getting warm. I don't know if this is detrimentally warm, but I don't know if this thing is supposed to heat up as much as it does. We are only consuming 0.18 of an amp. What about at... Okay, so it's like 100 millivolts on there, and then on the negative rail, it's maybe 20 millivolts. And then this down here, of course, is getting hot. That's the output amplifier, so that thing's running at 12 volts. This thing is getting a little bit warm but it's not running away. It's not thermally running away. I don't know. I don't like that that gets so warm, but let's just see if it creates an output, because if it does, then, you know, we're done. Make sure to plug the thing in right. I turned off the power, so we can play. One thing is, like, if you got larger capacitors than this on something like this, it would help to power down and then short out the power by pinching it on something. Like, take a pair of tweezers and pinch the power, the plus and the minus rail, just to make sure. I do have this plugged in correctly. We've been working with this module for far too long. But maybe I can make my own, because I've got access to the front and the back of the circuit, and we know most of the components here. My intro to C++ started with 18 kids. The last month, 2 kids. Oh no. That actually, yeah, that's actually, you can really learn a lot with that then. Yeah, my C++ class was just a big, everybody takes it kind of deal. But I had a good group of friends that I could actually, well, group of people I knew, I guess. I never made friends with any of those people. I had a group of people that I was working with that really helped me get through that class. Any class like that, I needed to have other people taking in order to figure out what the hell was going on. I needed study buddies in order to learn anything. One of the big things for me in college was learning how to learn. I was failed by my high school. My high school was English grammar, not engineering. I was a terrible fit. I mean, I talk good. I got good granulation. Make words. But still. Oh, there's a frequency generator back here. That's right. We got all kinds of stuff kicking around behind the oscilloscope. Hold on. Let's make some sense of that. So, I wish I had a place for this stuff to live a little bit better, where it wasn't all tangled up in its cells. Of course, my frequency generator isn't exactly super professional. It's a little bit wonky. We may need that. Oh, get back here. We may need this thing later in order to create an input for our device. But first, let's test to see if the VCO is just outputting stuff. Can you fix my keyboard? I broke it and ripped off the soldered switch out of this. You can figure that out on your own. You can figure that out on your own. There's probably 1,000 YouTube videos about that. Nope. And I can't fix your computer either, because I don't know how those work. So, all right, let's see here. Started with 27, ended with 5 people. Man. Those were the intro to engineering classes were like that. Those are the ones where they hit you with some pretty brutal equations and stuff. And they make you do a lot of math homework. And like, if you could do math homework, then you could dodge a wrench. And they threw a wrench at me. All right, so we have channel 2 with this signal. I can bring that up for you guys. Scope. Bada, bada bing, there it is. And we can see whether or not this thing works, because we know that if we power it up, we actually do have a response from it. So we can take a look at the raw output voltage from the out. And if nothing is happening, then I cry. 3, 2, 1, test. I cry. Every time. Channel 2 hooked up directly. Did I plug the right thing in? Yes, I did. Go to different modes. The trigger level I want to put on channel 2, so I hit the trigger menu, and then I go to channel 2. That's all I need to do. It's all on the right stuff. Channel 2 is DC coupled, which should be fine for us. It is centered for the trigger. I can move it up a little bit. We can see if anything is happening. How fast are we moving? We're moving at a pretty good clip. We should see a lot of stuff going on, assuming there was oscillation, but it doesn't look like there's oscillation. Oh, is it top right VCO out? I was on out, but VCO out versus out. Let me try VCO out. Aha! Well, it shouldn't be drifting. One thing it's doing is drifting. Out needs a trigger. Okay. Let's give it a little bit more range here. Let's give it a full host of voltages so we can go up to 6 volts. Seems like a little bit much. 4 volts on the output? Yeesh. That's our adjustment. Tuning adjustment. That seems to work. This one would be the VCF mod, which isn't doing anything on the output, on the VCO out. The VCF, I guess the main output needs a trigger, and then this one is, that's resonance. This one is cut off. That's not going to do anything to our signal right now. This one is VCO mod. We're not on that output. We're not looking at that output. Slide in, I think that, oh, that's an input. And then this one is triangle wave versus square wave. It appears to be a little bit weird, and I think that might be down to adjustment. The voltages are strong. Getting negative 4 volts, which is a lot. There's also the VCA in. I need multiple ins. Envelope filter out. Is envelope filter out's not going to give me anything, right? Eh. Yeah, it doesn't do anything. Ah! Give me this back! Jesus. Ugh. Christ. Yeah, that needs a trigger in order to do anything. Man, these are tight plugs. Okay, so this is just the amplifier, and it looks like it's a bit out of tune. So there's a ball detent in the middle. I'll put that to the middle. And it looks like both of these need a little bit of adjustment, and that's down to those 2 potentiometers, I think. So the question is whether or not I can even get to them. I don't know how Acid Labs did this. They probably have a jig that the whole thing can go into. Like, I can barely reach these things. I don't think I'm actually turning it. There's a little something going on there. Oh no, this is me slipping off of the adjustment. I'm trying to look at the wave at the same time as I'm adjusting it, and it's like impossible to stay on these things. All right, let's see. Yeah, it's drifting all over the place. It does drift. Like if I change waveforms. Up we go. See that? All right, back to this one and see if, oh God, touching the back of the circuit board is enough to make things go. Look at that. Okay. I think this top adjustment is going to flatten out our square wave. Or maybe this is just the square wave that we're supposed to get. It's supposed to be kind of a dirty square wave. Touching the tip of the jack is enough to make the trigger, and that would be at the gate in. So I need to get one of my audio cables in there. Do I have one sitting around? Nah, I can just go grab one. Is that changing anything? Nothing's changing. I wish I knew what these did. It'd be nice to actually know what I'm adjusting, because it's like I need to get rid of the little plateau there, and these should these be centered on 0? All right, let's do out, and then I'll do a touch the tip for gate in. Oh, here's a cable. I know it's looking at one. And then gate in is which one? This one. But that chip is getting quite hot. I don't know if that's supposed to be getting that hot. Why is it still getting so hot? I don't know if this thing is functioning. We're on gate mode right now. This is VCA in. This one's gate. Volume is all the way to the right. Decay, I'll put it at the maximum. So whatever it is, it should probably hit and remain. CF mod, back and forth. Resonance, cutoff, no cutoff. I think the filter's broken. Go to triangle wave, nothing. Triangle man, tune back and forth, doesn't, no, it doesn't, that's a center detent. Why is that heating up so much? Man. I mean, I could hit it with control voltages, but I just don't think that, oh wait, it's not plugged in all the way. Wait a minute. Well, that should have gone psycho if it was plugged in all the way now, so it's just not doing anything. We saw it was sensitive enough that if I just touch it, it goes crazy. Yeah, okay. So, I mean, the VCO potentially is working. It's acting a little funky. If I give it CV in, this is probably going to change frequency. You can see it kind of changes frequency, but let's give it like a, let's give it an actual signal. So channel 1 is going to be the frequency, the CV input that we're giving it. And so I will do a, power that on and let's get that set up first. This is a very basic kit frequency generator. So right now I have it set at 490 hertz at 10 volts with a 0 volt offset. So for basically we're going up and down 10 octaves with this signal, which is insane, but it is good to test with. Here's what it looks like. Oh, maybe we'll slow that down a little bit. So on the frequency, I'm going to go to frequency, and it'll be 1 hertz. So there. So that's our test CV. It's a low frequency oscillator. Why am I in fine mode? Wait a minute. Okay, well, let's just see what happens. So then we take this one, and we put it into control voltage. Whoa, whoa. So we can see here that it is reacting to the change in voltage by increasing and decreasing the frequency. So the oscillator portion of this thing works. Whoa, whoa, whoa. The filter portion of it is broken. Voltage controlled filter CV. Okay, so now we're locked in again. And then we can't really see what's happening like this. Hold on. Triggers there. I need this thing to not be... I guess we won't really be able to see the difference. We'll be able to see those changes. It goes up and down, I guess. And then the output... The VCO out is directly out from the VCO before the filter. So we need to look after the filter, which would probably be out, wouldn't it? But does this still need a trigger? I don't see anything happening down there. I'm like touching stuff to see if it'll do anything. Nope. VCA in is the next one down. Which, I mean, we're not seeing anything. Do we really need a trigger for that in the gate? We do. Ah. which this is a very rudimentary way to be testing this. Doesn't really give us any info. Nope. So it seems like the stage after the VCO is dead. So I think I probably need to go ahead and continue to reverse engineer this, because I probably broke it further. If we knew what Bin Gizmo knew back at that time, when I first received this, we wouldn't have had to go through any of this. I would have had to replace 4 chips and a couple diodes and stuff like that, and I would have been back in business with this thing, and Dave would have had a synthesizer back. But because we know what we know, we are just dangerous enough to really, really screw up something like this. I'm going to have to figure out... Well, I mean, even if I just give the trigger this wave, it'll still trigger it at around 8 volts. So if I give the gate in this, it should be triggering, but it's not. Play with envelope, play with any of these. And let's see, it's in VCA. If it's in gate, none. Nada. Check envelope out. That looked like something, but it might have just been me plugging it in. Nope, there's an envelope gate. I'm on gate mode. I'm checking the envelope out, and I've got a pulse when we reach about 3 volts. And there's a bit more. Okay. That's actually, wait a minute, that's actually a result. Bonk. What's up, Remdog? I mean, I can make a more definitive trigger out of this. I could just turn this into a... how do I do that? How do I do that? Mode? No. Waveform. Square. Let's do like 20 hertz. No, I don't want to sweep. Step size. Escape. And then amplitude. No. Frequency is 20 hertz. 20 hertz square. And we need channel 1 to be a little bit bigger than this because it's 10 volt peak to peak, which is causing our shit to go way out of whack. Hold on, number 2, bring that back in. Yeah, we're up here at 10 volts. That's maybe not the desired output. We got home late because of the B738 you were flying on? Oh my god. The filter, yeah, the filter's broken, huh? Although this is out of spec, but maybe that's part and parcel of the filter being broken. Stabilize that a little bit. There we go. Actually, that'll go back out of stability when I do that. Let's turn trigger to channel 1. Excuse me, sorry about the hiccup. It's too loud. Channel 1. Close the window. I need a big OK button in the corner. There we go. All right, nice and stable on that square wave. So now I can twiddle the knobs and see what happens. So the filter ones, what do we have? Resonance? Not really. Cutoff? Not really. Envelope? Nope. Decay? There's decay. You can see that it literally decays a little bit faster. Did you get a t-shirt for surviving a Boeing aircraft? Voltage controlled oscillator mod changes how this thing responds to CV. This should change the frequency, and it's not, because our trigger is the only thing that's being expressed here. There's nothing feeding into that. If I change the waveform type, it doesn't affect the filter at all. So yeah, something in between the two. Well, that one should change it into an amplifier, and it doesn't. That should be amplifying the oscillator back and forth. And that settling in was unsettling to me. It looks like any of the envelope stuff is just not fun. The only control that I have is decay. That's the only thing that's actually functioning right now. What am I probing? I'm probing envelope out. So if I look at out, well, not triggering anything either, so. Yeah. And I could hook up another line and monitor that other one, but. So this is creating an envelope out for a control signal. Amplifier in here. It would be cooler if this thing worked. This thing ain't work. There's the oscillator's output. There's the square. It's a busted square wave. And of course I can tune in frequency. And if I enter this as a control voltage, it's going to be high, low, high, low, high, low. That's not doing anything. Why not? That should be going from the highest to the lowest frequency back and forth. Oh no, that's voltage controlled filter. The oscillator in and out. There aren't enough waves in between our waves in order to observe it doing anything. Yeah, I don't have a lot of outputs going into this thing. There you can see, I turn up the effect a little bit more and you can see that it's like, you can barely see that it's low and then high frequency, depending on where, if it's up or down. No, it doesn't, because we're dancing around the filter. The filter does not function. I don't have a good way to split off more control voltages than this in this setup. So either I let Dave try to test it. I don't think we saw... Yeah, it seems like we have a voltage-controlled amplifier, we have a voltage-controlled oscillator, we have a voltage-controlled filter, and we have an envelope, or a ADSR or something like that, all in this package. And it seems like the frequencies aren't getting to the filters. Because we can observe an envelope output from a trigger, we can observe the voltage-controlled filter CV doing stuff? No, we can't. We don't see the amplifier doing anything, we don't see the filter doing anything. We see no overall output, but we do see an oscillation controlled by a voltage-controlled amplifier. There's two other pieces of this that aren't functioning. It's possible one of the others does function. The voltage-controlled amplifier might function just fine. It's just not getting anything. The filter is, I think, the next piece of that whole thing. There is a block diagram if we look up the TB303. What does the filter do? It's a transistor ladder filter, and you'll have to look that up on your own and read about that, because I don't know nothing about that. But it is a transistor ladder filter. There's a bunch of transistors there, and it gets a voltage input, and it's able to produce some kind of a cutoff sort of filter, I guess, or something. How warm is this component up here? Pretty warm. I mean, we are seeing oscillations on the output. I mean, it's clear enough as day on that diagram up there of everything functioning. Everything appears to be functioning just fine. So the question is, what's broken in the interstitial stuff that makes this synthesizer work? I don't like all that heat up there. I don't really know if this thing should be heating up as much as it does. I guess it's okay. There's no heat anywhere else on the board. I mean, there's little bits of heat around some of the functionality areas of the board, but yeah, there's how much does your control voltage input control, which you can have it do nothing. You have it do its maximum amount of control. Then there's the fine tuning, where you do just a little bit of up and down. And then this one is the voltage control filter mod. We're not giving that any kind of an input. So if I split off this signal into more, I need to go get wires in order to do that. Let me get some wires. I mean, but then we're controlling two things in the same way at the same time, which doesn't make it all that good. And where's a splitter? Here is a splitter and a wire. We can just do another output from this cluster. This cluster truck. Then I need one of those thingy-majigs. Where do those go? Is that on the end of the one that fell? Of course it was. Of course it was. Do a Chris Chan sigh. Where did it go? I had another one of those things. I don't know what happened to it. Probably gonna fall on the ground as soon as I try to move stuff around, you know? All right. Well, I can't plug it in unless I have the gender bender here. Did I like push it over here? Is it back behind this stuff? Nope, I don't see it. All right, so it's probably it's probably over there because that's where the other one's over here, but I don't know if I put it away properly. I think it's possible the filter doesn't do much to a square wave. You need a saw or a sine. I mean, I could give it that. The signal flow, you found the signal flow? What chip is getting hot? An op amp? No, it's a quad, or no, a 5 transistor supermatched pair chip. It's the one that's doing the oscillation. That's what the supermatched is all about. Why am I not seeing my input on this? There it is. VCO, VCF, VCA out. Wait, but where's the envelope? Is that... There's all kinds of other shit. It's so complicated. A little reverse engineering would probably, you know, give us a better impression of what was going on. It would at least have me memorize the layout of the chip, the layout of the circuit, rather. So I would know what's going on and be just as confused, but with more knowledge of what's happening. Where'd that... Oh, it's been over there. That's not all my connectors. Where'd my RF connectors go? RF connectors are... Which one? Where? Oh, they're there. And if I was kind to myself, I would put things away where they should go, which would mean that it was right here. It's not. Because I knew I'd come back and be testing stuff, so I put it on the end of the cable, and I think it was the one that dropped down. So now I got to crawl under the desk, and I got to find this one connector. It's the only one that I have that'll fit in this specific scenario. We're trying to, I mean, I guess I could bring over another module and power that up too. That seems like more effort though. Oh wait, there it is, I just saw it. I put it back behind the scope. It's over here. Look at the CPAP connector. Look, what's that doing over there? Here, let's make this a little bit more ridiculous down here. Yeah, Dave is the one who knows more about this module. Why isn't that unplugging? Is it stuck? Okay, and there's an empty bottle of soda sitting right in front of me. Remember, a good artist gets mad at their tools. Oh, I didn't need the... if I did it in this configuration, I would not have needed the gender changer. There we go. I need like BNCs that are a bit more light than these, because that frequency generator is very light. And as such, oh my God, look at the waves. It's very light, and as such, when I move these BNCs at all, it goes psycho. Why isn't that making a good connection? That should be rock solid. Oh my God, the things I do for this shop. Come on, man. What's your problem? Are the BNCs like worn out on this thing? Or maybe it's just the quality of these cables are terrible. Yeah, that appears to be it. It might be the quality of the cables. Quality of the equipment is low. All right, don't touch it. Don't touch it. We're doubling the output on one. And so we can do both a filter and a control voltage at the... Damn it, we lost it. I moved this ever so slightly and it eats the rest of the signals. So what are we actually going to be testing here? Do we do oscillator and gate at the same time? And then we observe the output down here. And then I observe on the fourth channel, on the third channel rather, the oscillator, the OG oscillator, which is VCO out. And then I make sure that my signals are actually going into the right stuff and that everything is powered up, which is not the case right now. So can I just get output from you, please? There we go. Nope. Let's turn on channel 3 as well. Oh, come on. These BNCs are very low quality and I'm not happy with them. I mean, like, you saw, I didn't touch anything. I didn't touch anything. We good? Okay. Blue is our output. Purple. Oh, wow, I made a squeaky noise when I said that because of stuff in my nose. Blue is our overall output. Purple is our VCA output. So if I adjust this up and down, we can see the frequency there changing. If I make the control voltage more influential, it will change the frequency output according to the square wave. The square wave, which is also going into a trigger signal, the gate input. I could modify the gate envelope and stuff, but we're not seeing an overall output. So something in our functional diagram, something in our block diagram is not, one stage of this amplifier is not working. There's a couple things that it can be. Let's open up the TB303 block diagram. Actually, you know what? I think Acid Labs has it in their data. It's just it's just a photocopy of the original. So TB303, sorry, oh, there it is, service manual. Roland TB303 service manual. These things are so popular that, of course, you can find this stuff everywhere. And I think I have these saved into directories. The envelope controls the cutoff in the filter and the volume in the voltage-controlled amplifier. So if this thing is it's in gate mode. If I turn it to VCA, yeah, what it should be showing in the output is it going from loud to quiet then. And it's not doing either of those. It's not showing an envelope, and it's not showing a sort of a loud to quiet kind of thing. So here's all the parts they use to make the TB303. All bets are off for the one that we're doing. The M303, the Acid Labs module, uses different parts, but with similar functionality. So, I mean, like, here's our inverting Schmidt trigger. But when it comes to stuff like, you know, the sequencing and stuff, we're not, you know, we don't got any of this stuff. Now here's the diagram. Voltage controlled oscillator, voltage controlled filter, voltage controlled amplifier. So our checking the gate, the trigger, the accent, all that stuff is useless if our voltage controlled filter is doing nothing. And it looks like the first stop, aside from a summing filter, is a TRC ladder, which is a transistor ladder filter. And then there's an amplification stage, and then we go over to the voltage controlled amplifier. So the voltage controlled amplifier, for all we know, could be working. I don't think there's a way to bypass the filter. No, there isn't. There would be like a switch or something for that. I mean, I can turn the modulation of the voltage controlled filter all the way down, but we're not getting any kind of an output. Cutoff and resonance. Yeah, there's something wrong, so we're not passing anything through. Troubleshooting electronics. We're doing it. We're doing it. My God. Okay, so the VCO, waveform selection, and then this is just sort of an overview. Now there is a schematic on this thing. There's an actual like part for part schematic here. It's a lot. It is quite a lot to deal with. Here's the amplifier, the filter. Where's the oscillator? And they have little diagrams for what's happening at every like for all the waveforms and stuff like that. It's really, really good manual if you can open the thing up and poke around at it. But for us, we can't open it up and poke around at it because all the controls block the rest of the circuit. So unless we had test points where we know to drop in from the other side of the circuit board, which I guess we do. We kind of do. Like, we can look at the different outputs around these transistors. We could actually poke in on those. Why is the filter... Well, oh, because they're all going out to a bunch of... Yeah, this is a very weirdly organized... Whoa. Okay, that's the layout. Where's VCO? Looking for either two transistors facing one another, two bears high-fiving, or something that's labeled VCO. Tempo. Main board. Yes, yes. Oh, are they using like a transformer? No, no, no. Power supply. 417 something or other. Tune and width. So this would be the oscillator right here. Yeah, 1 oct per volt. And these guys, I think it might be what's doing it. Oh, VCO. There's our label. It's just this thing is like get out of the way. Let me see the rest. My bet it's the filter. It probably is. Oh, so this is what we're supposed to see. It's just off by a bit. We're supposed to see kind of a little bit of a rough, like our waves. Well, I don't know. Our waves are a little exaggerated from this. This is very similar to what we were seeing. It's just it wanders around in the voltage level. R105 10K. Where's the adjustment? Is there an adjustment here, and what does it adjust? Yeah, there's some stuff I still need to take a look at in here and make it work properly. Oh, there's an adjustment. They don't really say what it is, though. Oh, I see. This is what we're supposed to see at those points. Then that feeds into the waveform selection, which I can't really get to the test points on that one, but we could probably see two waveforms going into the top layer of the board. And then from the selection, it goes to the filter. Okay, all right, all right. I see. But yeah, whatever's supposed to happen in the next stage, the voltage-controlled filter, we are not seeing properly. If we could find... Well, the input to one transistor goes back over to the oscillation. And the oscillation is coming from two different pieces of that part. I don't know if we'd be able to really find it. It's kind of a tough one. Somewhere in this circuit, we go over to the next stage. With two different signals, it would go over to either... So hold on, it's being created here. This is that transistor, quad transistor. We've got two adjustments sitting over here. And really fully get those connections. And then we have a header right here. Somewhere on that header, we would see two waveforms that go to the switch. I didn't get a picture of the front panel. I guess I'm keeping it because it doesn't work. It clearly doesn't work. But then somewhere along the line, somewhere around here, this goes to the next stage. And the next stage might be one of these, but we do know that there is a transistor filter sitting right here. Somewhere over here, we get that signal coming all the way over to there, and we could probably follow it if we can find its origin. So if I can find its origin, maybe on the header, if I ground my probe, which is already grounded. So I'm going to plug the probe into channel 4. I got another channel going here. 4 has to be much more voltage than this. Microvolts? No. Millivolts, volts, there we go. All right, we'll check 6 volts, and that'll be enough that we can see what's happening. And then a probe, which is over here. Plug that in. And now, I don't want to hurt the transistor thing. I think I need to probe in on the plug itself. And if I move, then my signal, my input signal gets screwed up. Oh, it already did get screwed up. Why is this thing persistent and just fighting me? Why are you fighting me? It hates me. It hates me so much. And it. This is like, everything I'm looking at is a rat's nest. So this should be grounded. So I should have the, what channels, what does that even look like? It's like the darker purple? I don't know. The blue channel. Really? Because 2 is blue. 4 is blue as well? 4 is like a different, it's like an indigo. Well, I can already see one of these going down there to that switch. So what's this one? Nothing. Oh wait, no, I see it. So there's one of the signals. Is this on the other one? No. What about you? See, the one that I see going down, but that seems to go down to ground. I don't know if that's quite accurate. It seems to follow the main signal, though. I really gotta crouch down on this. Okay, hold on. Let me go so that you guys can see what I'm looking at. This is a very confusing. I guess I could turn off channel 3, but you can see on this line that I've discovered right here, we have the exact waveform. It's just at a different voltage level. I look around it. What's this one? No, nothing. Oh. Above it. So I should have a triangle wave on one of these. Supposedly. Let's look for that triangle wave. I ain't seeing it. What if I go to ground? Like case ground. Okay, no, there's some stuff going on, but nothing quite like what we wanted, which is good. I mean, this is the TB303 sends the waveform all the way to the switch. This might not. Considering that they were built, what the? Oh, that might be our triangle wave. Let's check. Let me switch it over to triangle mode. That'll be it then. Oh, this is, wait a minute, what's, huh? Wait a minute. Square wave, triangle wave, nothing coming out. You look like our triangle. Flip it over to square, it doesn't change. So that's triangle input there. And it looks like it's been corrected. Because it's not wandering. So whatever's going in there is clean. Our inputs after the switch are clean. What are you? Okay, this is our output. I gotta label these. So that would be this one. This one is our triangle. And then our square's all the way over here. Okay, so according to this, we flip that over, and then which one is it? I gotta do this real quick. We gotta figure out which pins I was just probing on this, which means it's 180 degrees flipped. So on the bottom row, 1, 2, 3, and 4. This one and this one. I'm gonna make a new layer for this just so I can scratch notes on it. And I'll use a pen, and I'll make it white. I don't want to change up my colors too much because I'm doing video editing, and I need these colors for my on-screen labels. Is there a diode packet for the diode ladder filter? I already showed you. It's a transistor ladder filter, and there is a grouping of transistors. It's up here. I said it very briefly, but yeah, there's the ladder filter. And I believe that these are dual transistors. But that's all the way over there. We're looking at where the signals are on the plug, because on the TB303, they run two waveforms to the plug and one waveform from the switch, I'm sorry. So I'm trying to figure out what pins go to the switch. I think it's some of the ones over here. You know, we probed it. We know it's a couple of these. So 3 pins in, and we have that's, oh, you guys can't see it. I have the square waveform. Only the square waveform. Triangle. No, this changes it up depending on which one I'm switched to. Okay. No, wait a minute. I have just the square waveform because the output is what's changing. Yeah, so 3 pins into this, the three from the bottom. This one would be the output. I don't know where to draw this because it's like here. And then here. Oops, no, I don't draw that. What? It changed my, it changed my tool. Back to the pencil. It's like here and here. Like this. Or is that one the output? Okay, I gotta double check. So this one we get the square wave from, or is that still the square wave? It's still the square wave, even though our output changed. So our output is changing from triangle to square, but our input is still square. So that one's square, then the one next to it does nothing. No, the one next to it changes depending on what I'm flipped to. So it's square or it's triangle. These would be like offset square, which is a little weird. Square or triangle. Our waves are changing because our control voltages are coming in there and changing it from high to low frequency. I mean, I could switch it off, but so this one is our output. The second one is our output, and our third one is triangle. Oh, okay, so the 3 just next to each other. So which one was our output? I keep forgetting. That's our output. The middle one is the output. So actually, I could just draw like a slider switch if I really want to. It'd be like that. That would be technically the way to draw it. If I really wanted to draw a slider switch, I could use like a button symbol, but let's do the traditional slider switch. Let's just do 3 dots. This is an old school switch symbol. And then we just do like that. So that would symbolize the slider going from one end to the other and selecting. So on the left is square. And this one is triangle, or sawtooth rather. So sawtooth, triangle, and then out. Or I could just do square slash triangle, because this is sorry, slash sawtooth, because that's how it is in the diagram. I know it's kind of blotchy and sloppy, but this is enough that I'll be able to look at this and go, And then I can also make it disappear. So where's our output going? We found our output. So our output goes, and let me make another layer for stupid notes. Layer 4, stupid notes. Our output goes along here, into the capacitor, up, around, and then for some reason we're going over to this pin. So the second pin in, what? Okay, hold on. Second pin in. Wait, but that doesn't have anything attached. Well, not on that side. So on this side, what I'd be able to see is, yep, a DC eliminated version of the waveform. Somewhat. Yeah, it's eliminating the negatives or whatever. Or it should be centered on that. Yep, it's going to eventually be centered on it. I guess. Slowly it builds in. We got to figure out what's making it do that. Make it stop. So it has some stable waveforms. But either way, we are indeed seeing what we thought we would see, which was the other end of capacitor, which is eliminating the DC element of this signal, which is already gone. So I don't know what the hell that thing's doing there. Bad cap, yeah, or one of the ICs is just completely destroyed, and so all that's on that line is a capacitor, maybe? I don't know. I'm not sure. And I messed up with my lower and upper layer markings around here. It also goes through a resistor, and it goes up to this pin. Why? I think there's another amplification element kind of thing going on. So if I look at it on that pin, it'd be a slightly lesser version of the signal. They really like sending the signal to the top layer of the board, don't they? It's also possible that I'm not getting a good ground, and maybe that's what's causing those drifts. Let me get a better ground. Let me plug into a ground that I know is grounded. Make sure that my channel has a good ground on it. Now they're still wonky. So yeah, a lesser version of the signal we had before. But this one should fall in the middle eventually. As should this one. It does eventually. Okay, so from the top, I do not know where those pins go. I don't have a good picture of the top and the bottom board. This would be where if I had all four of the boards stacked on top of each other in my documentation, the GIMP drawing, then we would be able to trace it fully from one end to the other. But I can't do that because I don't have the document put together. I'll have to get pictures of the top and the bottom. If we know now that we need to go through this whole thing and figure out exactly what it's doing, then yes, I'm going to have to get the full piece of information. These offsets here just are down to the photos being a little funny. Because from what I'm seeing now, okay, what did I see? What I saw is that in this schematic, from the how to repair your TB303, I saw this weird thing where they were putting waveforms onto a line and tracing that all the way back to a switch, which I guess is totally fine for your musical equipment. From my perspective, you can have like a thing that switches something, like you can have that waveform switched to an output in a more kind of digital way and not have to have this ugly switch there to go and make it. I guess this is a hell of a lot cheaper than doing it my way. So but I thought it was kind of funny that they were running a waveform all the way out to a slider switch, which is a slider switch is a piece of metal. It's literally, I can show you guys. Why would you do this? I mean, the simple elegance of it all, but it's not really that elegant. It's kind of sloppy. I guess to a degree, you're trying not to pinch every penny, but you also don't need to spend an incredible amount of effort doing stuff that, here, look, any given switch. Oh, I'll take one of the switches that I have tons of. These things are mostly throwaways. They're very cheap. But like if we take one of these apart, you can see like your toggle switches, there's not much to them. I'm willing to sacrifice one for my stream. Every day I will sacrifice a toggle switch. All right, can I actually like find a work area somewhere around here? Right, digital switching back then. Well, but we had digital switching back then. It's not, digital switching doesn't mean that you're adding $1 million to the cost. You're actually reducing some complexity Pyro Esp has subbed at tier 1 for 64 months. Pyro Esp, thank you so much. Hey, by the way, those of you on YouTube, and I don't mean to single you out because there's only one of you. No, there's a couple people on YouTube watching. It's just only one person participating. Over on Twitch, you can subscribe to my channel for $5 a month. And sometimes a little bit of that money makes its way to me. Whenever Jeff Bezos is all stocked up on head wax, he'll send the remainder to me. It's like a couple bucks. It's kind of nice. It helps me do this stuff. Pyro's in bold. Yeah, Pyro's my ever-present and totally necessary YouTube moderator, because we can see how rowdy YouTube gets. I'm not popular enough for that. You know, I'm not like one of these YouTubers that comes over to Twitch and has a ton of people. I started with Twitch. I cut my teeth on Twitch, and I probably shouldn't have cut my teeth because that was kind of not something I had to do. Hello, I found your channel recently. Well, why? No, I'm just kidding. How's it going? Hello, I found your channel. And I'm like, what the f... No, I shouldn't be rude. It's funny to be rude. So, don't cut teeth. Yeah. I use that phrase a lot. I probably shouldn't. Okay, so inside of any old switch, there is this terrible, sloppy mechanism that is literally just... Oh, God, I got to do the other side. Horrible, sloppy mechanism. That is just a piece of metal contacting pins. This one might have some stuff. No, it doesn't. It has nothing. These were cheap. These were cheap. These are cheap Amazon switches. And these switches have absolutely nothing but a little bit of grease on them in order to prevent sparking. Now, in the more expensive industrial switches, you will have a bimetallic puck that is designed to kind of mitigate sparks inside of these things. But these were bottom of the barrel, which is, it's kind of interesting tearing one of these apart, because I got these at bottom of the barrel from Amazon, whereas the nicer versions of these, the ones that you would buy from like DigiKey, actually do have a little bimetallic puck, or sorry, an alloy puck on the end, in order to mitigate the sparking that happens when you flip 125 volts on these things. Because these things, apparently they're rated to 125 volts. You're not going to get very far with that. See that? 6 amps at 125 volts into this? Yeah, I don't know about that, bud. You know, it might work for a little while, but again, I use these for low voltage DC. I don't use these for 120 volts. I don't trust them. I don't trust them, man. Like, what? You got this isolated, this is supposed to be grounded, but like not a lot of plastic there. I guess that is a lot of plastic, but still not a lot of mitigation of sparks and things like that. But anyway, you can see that literally the mechanism that we're looking at is a piece of metal smashing against another piece of metal in a controlled environment. But it is a piece of metal smashing against another piece of metal. Oh no, for the price I got these, yeah, of course. For the price I got these, this is going in the garbage. But so what I'm saying is that in like an environment where you have audio, like that switchover is going to be very dirty. It's like you're going to have a very gross audio switchover. And then if you take apart an actual slider switch, it is just a piece of metal with 2 like U-shaped bends on it that gets moved from contact to contact. That's it. That's all there is. So when I was like, oh, this thing's going to be switching the audio over, I thought there would be a slightly more mature mechanism on that, but I guess this is fine for just your normal old, you know, synthesizer needs. But so the common pin then comes back over, and that's what we're tracing. So okay, so we were talking about my mentality before I took apart the switch. What I did is I saw waveforms going directly to a switch and said, hey, we could pick up on that where the M303 goes from the back panel to the front panel, because the front panel has that switch. So we can find on one of the pin headers what some of those pins are doing, and that'll help inform us, because we saw there's a voltage controlled oscillator, there's a voltage controlled amplifier, there's a voltage controlled filter, and it's actually in the oscillator goes into filter, goes into amplifier. And if we have nothing coming out of the end, then one of those two, the amplifier or the filter, are broken. So we need to figure out where that signal's going. We need to trace it out as far as we can. So that was a nice, easy thing. We figured out that we know where this is. Assuming that the two designs are the same, because remember, we're looking at the basis of design for the main thing that we're trying to vet the functionality of. So we go down here and we go directly into, after a capacitor, resistor capacitor, we go directly into one of the transistors that is a matched pair. That's what that little joopity hoop thing is. No front panel controls interact with that. So where can we pick up on something like a waveform? That's pointing to one of the pins of a potentiometer, which is which one? One of the two resonants. I'm surprised every time I watch how confusing your world is. You guys are smart. Ah, thank you, Project Alpha. It's not that complicated, though. It's okay. So the logic of what I'm doing is boiling this thing down to its component parts. And I have knowledge of how this kind of stuff does what it does. That's not totally playing into what I'm specifically doing right now. I am looking at, well, this is the design that they used to build this thing. It says this should be here, that should be here. So on this new one, this should be somewhere, that should be somewhere. Let's find that somewhere. And the rest of it is just knowing what to poke and prod. And actually, those offsets are not what we have. Our voltages do not look quite like these. No, there's no clearly labeled in at the filter. No. Because we're talking about internal circuitry. There's no plug that has the input to this thing. Although on the modular synthesizer one, there might be. Well, no, there's VCF in, which I think is just to control the voltage-controlled filter. We have accent in, gate in, VCF in, and VCO in. Basically, there will be control voltage structures that will control, that will influence the values of, basically moving the knobs for us. That's going to be a little bit different, more complicated than what we're looking at here. What we're looking at here is something where the person playing the synthesizer decides what those values are. So we just have potentiometers. But those potentiometers could have an alternate voltage coming in from somewhere else, external. Actually, these might, I don't know. I'm so confused. Okay, so we have a matched transistor pair. I'm wondering if that's what we're looking at now, or if we need to, I mean, this signal comes here and comes in to that. That might be the big one. Is it an external audio, or is that a control in for the, well, VCF in and VCF mod would be how much it mods per thing. But there's VCF control voltage and VCF in. So I think you're right. VCF in would be an audio input to use with the filter. I think you're correct about that. So VCF in is that plug above gate. And lo and behold, I can see from here, even from this view, I can see why kids love the taste of. So that would be going, show you, we'll get a little closer. Kids, scooch closer. Kids, it's the Emperor of Arrakis. Scooch closer to the Sardaukar. Okay, so we're coming up and around. Very clearly, up and around, and then down. And I don't know where down goes, but if I poke in on this, I don't think I can poke hard enough to get through there. Oh, there it is. So there's our signal. So if we plugged in an external audio, then it would cut that off and put audio into the filter. So we're still, our signal chain is still broken after this point. You could probably mark this down on like a block diagram. Where does that go? All right, so now I need to turn this thing off and split it apart. We can see where that goes. I mean, really what I should have done is get photos of both sides, but you guys are in my wheelhouse. Welcome to reverse engineering, bitch. You're in my wheelhouse now. So we are right at the corner of that. That goes down, and it goes to the first pin of this connector. So first pin of that connector does audio in. So let's do... Oh, which side was that on? Hold on a second. It couldn't go to there. I could ohm it out. Oh, the multimeter, I'd have to unplug everything. There's no way that it could go to that connector, because that connector is... Oh no, is that one? Wait a minute, hold on. Get my bearings, hold on. It goes to the upper right, which is the lower left, and the lower left we see coming into a resistor, which doesn't make sense because that's in the audio path, and that would need to be cut off by the connector. Say that for anything. Well, okay. Well, what happens when I plug in an audio signal, or when I just plug a plug in? I'll plug a plug in, plug a plug a plug a plug 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 plug. I'll plug a plug in, and we'll see if it cuts the audio on that pin. So I plug in here. Above right, that goes into the cap. This one here, not sure. I think that's a power line. I'm not totally sure about that one. I don't listen. Everything I know is on here right now. You guys know everything I know. So if I look at that pin again, look at this one again, I should not... Why is everything blank? Oh, because I turned it off. Turn it back on. Burp. Okay, wibbling waves. And then I plug in on this over here. I don't want to plug in on this over here too much, because it'll damage the pin. I don't want to damage the via. Yeah, there's our wave. That's our output. So flip it. It flips the square. Funny, it looks kind of out of phase. And then that should go to... I think it goes to the bottom pin. The top pin... No, the top pins are square wave. Wait a minute. What the... Oh, I'm on the wrong pin. Sorry. Why am I on the wrong pin? Like the wrong pin. It's funny. It almost looks cleaner when it comes out on the... Oh, no, never mind. There it is. Yeah, that one's just not doing anything. It might be a ground. But wait, I have something plugged in, so it should be cutting off the audio. Perhaps I misjudged you, Trace. It wouldn't mix with the thing. What do we have on this? Wait, when I plug in this one, what do we have on the end of this pin? Okay, nothing. That's good. Or ground noise if I touch it. There's our ground, a little bit of ground noise. So this pin on the end should, I mean, like we trace this trace over. Maybe that's sending it to that. So now we need to find the other end of that plug. So I guess that would be the sending pin. Oh, good. One of them's ground. Another one of these should be the switched pin. There's that one. It goes there. That comes around and goes to what looks like... Oh, I see. It skips under and it goes to 3 in from the right. 1, 2, 3. Flip that around. That's going to be... Okay. It's going to be 1, 2, 3 there. it's going to be here. F in. And then this one goes to the filter. To F plug. I need to make that a little clearer. The F plug. So the audio in, I don't know what this one's doing, but the audio in goes from here to the switch to this pin here. And so that pin there, and we'll verify that it'll have no signal on it. So let me plug the two halves of the board back in, and then I'll power it back up. What we're doing right now is we are following the audio signal on this board, and that will tell us what the next broken area of this circuit is. So if we follow our signal, we can eventually find what's going on. Why is purple doing that? Purple is 3, which is our something or other. That's one of our controls. Oh, well, when we turn output back on, it'll go back to wibbling. There it is. So if I go 1, 2, 3 to here, I don't see anything until I unplug this cable, and then I see my waveform. Bada bing. Yeah, having the scope like this helps me zoom in on what I'm doing over here, and you guys get a much clearer picture of how this thing is functioning. You guys can see what I'm doing and how I kind of come up with the next step of tracing this thing, which is kind of cool. Nice to have you guys along for the ride. You guys can check my dumb logic. But yeah, so with this unplugged, we are sending a wave all the way to, and what we've gotten to now is hopefully the filter. Tekken is 3. Huh? It's fun. Yeah, it is kind of fun. Okay, so yeah, just like Wonky Robot said, we can process external signals with the filter, and that's through this plug right here. How simple is this? We basically waveform here, and that splits off in the double, and then it comes over to here, and it goes into this one, and that one is this, and then this one over here is unlabeled, but there's the labels for them, and you can see that this one is there, and that one there, and then the thing we're looking at the VC out there, and then that goes over there, and over here, we have the power hookup, which has the plus, minus, and the negative 12, and that's going over, all the way over to my Agilent power supply, where I've got the 12, I've got the negative 12, and I've got the positive 12, and then there's ground in there too, and then those come over here, and then we have a switch that I took apart, and the parts are right there, and then we have another cable here that I'm using in the blanket out, but it's not actually being used right now. And then, oh, there's a scope probe too, yeah, and a screwdriver. Testing ain't easy. Okay, so frequency input is coming into this pin right here, and it goes, and we'll go over to my scratch pad layer, up and over. This is following the sloppy notes that I did before, and it goes to one of these transistory doodly pins right here. It really does look like it runs into the other pins there. What's going on with that? Maybe one of these is supposed to be on the other layer. Oh yeah, it looks like this whole thing is supposed to be on the other layer. There were some mistakes I made marking things on the wrong layer, so that's probably what's going on here. So this second pin of the 07 whatever Schmidt trigger? Is that what we're going into immediately? It seems a little odd. Oh, but we're also going out this way. To one of our adjustments. Oh boy. Oh boy. So let's just, oh, I can't probe on these. Oh, but I can probe on the other side. If this thing is jumping over to the other side, then I can actually grab it there. Where? That's going to be in like dead space. Where the hell am I going to find that? There's a via there. So as it comes over and it goes to this via here first, And then it goes on the top layer of the board, it goes over to there. Oh, but when it goes over to there, there's another one coming out of there? No. I see. One goes there, one goes there. One goes to here, and the other goes to there. Hold on, we're still finding our frequency here. Why would you send one of them over to the Schmidt tree? There's two there. So we're going here, but we're also going here. And so that one goes up here, up and over. It's a big capacitor. Huh? Why would it go under the... Kind of lost it. Yeah, it's like I don't really know what's going on under there. It just goes there. Maybe the capacitor's filtering it or something? Huh. Maybe it's just a big capacitor to ground right next. That's a big one, though. And it seems like that's a power pin. And yet we trace that out, and we know that that's connecting. Or, oh, wait, maybe it's not. Hold on a second. Oh, maybe that's not supposed to get a via on it. Oops, wait, I need to redo that. I can't redo. Oh boy, I lost a marking. Oh no, I didn't. No, we're looking at right here. Yeah, so it does go up and over, goes this way. And then, ignoring my mistake, it looks like I didn't undo the mistake over here. So that's what's going on. It's this isn't supposed to be connected. This is supposed to go under the board. Like that. And then it goes to this junction here, which is still just as confusing as it was before, but it's totally avoiding that 074, whatever it is. So then we go up to here. And still just as confusingly. So this trace is traveling somewhere. It's taking a signal somewhere that we're following. So we're going from here up, and we keep moving this way. Up and up and up until we reach under the capacitor. And under the capacitor, well, okay, well, that's pretty clear. It looks like it just does that. Oh, we can't see the trace because it's so bright. Oh, or whatever. So this is all still good. We know this is all still good. The signal coming up here goes down here. This is definitely like, I've designed all the other pieces of this. I need to connect audio in to the next stage. Where's it going to go? Oh, and you make it route all over the place. Because, yeah, it jumps over to here, then it goes under in order to go under that trace, then it goes over, then it goes to a component. So then we have an R and a C. And our signal's still going through here, goes to the RC, which does not go to ground, doesn't go to ground. And then we're at mystery chip number 2. Mystery chip number 2, pin 2. As well as some other facet of, whatever that's doing. Oh yeah, that's just a blotch of solder. Oh, and then it comes back over here. So this might be an amplifier. Well, hold on. Then we're going over here to where there's a bunch of diodes. Diodes to ground and stuff. Taking a signal off, going diodes to ground. The voltage controlled amplifier. So there's that, and then on the diodes, we go places that I don't want to fathom at the moment. And we go up to, that's power. So we have, oh, I see. This is limiting input signals. So this might be a shot, oops, did I undo multiple things? Undo cut layer, whoops. I hit Control X instead of Control Z. So, okay, this is one of those things where you've got the positive and the negative power on your diodes so that any external signal that comes in doesn't blow up your whole circuit. That's what that is. So these are protection diodes. And if I could probe the top side of this, I could actually test to see whether or not they're functioning properly. If any of those diodes are the ones that are dead, we can key in on this signal somewhere. We'll have to figure it out. But yeah, so that's coming from over here, and I guess, well, after that, a bunch of components go in there. But there's our transistor ladder on the one side of the circuit, and our signal in comes in here. It's not the first stop, that diode thing. I would put the diode thing as the first stop. We don't know if that's precisely what this is, but it looks like this little junction right here, this little swoop-de-hoop that's underneath the chip, I might be able to get a reading on. So I'm looking for something that looks a little bit different than that, but it will be in that area of the circuit board. So flip over. Oh boy, where the hell am I? Well, we're somewhere next to these, and there's our little swoop-de-hoop. So assuming that I'm right, we should see our signal right there. Once I get contact, I need to kind of like force the solder mask out of the way. So twisting and pressing in is kind of the brute force way to get in there. Oh, and I need to unplug this. Well, we just saw that that was a flatline signal. Oh, it's unplugged. Okay, never mind. There should be a waveform on this. Here. Huh. That is a result. Unless we somehow got confused and that's actually a voltage line, this should have a waveform on it. And instead, it has 5 volts ish. 5.2, 5.4 or something. I don't know. There is another place that I could pick up on this, and it is not easy for me to fathom. It would be up and to the back and to the left, back and to the up and to the left. I don't think that's, no, hold on. The spatial orientation of this thing makes it very confusing. It'd be like down and over, so it'd be like over. This one? It's still flatline. I don't think that's it though. I don't see anything on the transistor filter, although I'm not sure what I should be seeing on that. Okay. So I found this little junction right here, this little junction right there. It's pretty easy to find. If I go the opposite direction of the two here and find this one all the way over here, I can double check. Where else could I double check this signal? There's these two here. They don't really have anything that I can, well, if we go from that via, that big via, well, there's one out in space and there's one over here, and I need to somehow triangulate this. There will be a flat bar above the area of these two. So look for this, look up, and then we find a flat bar, and that's where I should test next. Bada bingo, bada bango, bada boom. I'm just kind of twisting this on the via just so I can break through and get a test. Oh, that's us. There we are. So we made it to there. We made it to the flat bar. We didn't make it past the capacitor and the resistor. So now we need to drop out and ohm it out. So we've tested now. Look at this. Look at this chat. Look at this shit. We're fucking this shit up, man. So we tested here, and our waveform is here. And we've tested here, and our waveform is not here. So between these two, we have a resistor and a capacitor. So now we go to the multimeter. So turn this off. Look at this. Can I cook? Can I cook? I can actually cook, but I can also electronics. I guess one thing this does do is allow me to just remove this, and now I can actually just work on the PCB. That's the advantage, I guess, of having all those bits and bobs on the front panel. So we're right here, and this is what we're testing. Doesn't look like much is wrong with this. Don't see any strife from the capacitor. All right, move out a little bit. Twitch chat is just flabbergasted. They're both flabber and gasted. I guess all I'm going to have to do is drain that carbon fiber out of the little desmellers. I keep looking at this thing sitting over here. Let's drain the carbon fiber out of the desmellers. I'll have to find a new way to hold in that powder to make air pass through it properly. So I'll have a more reusable carbon filter. I mean, it's like putting it in a loose bag. It's so loose that it creates too much of a seal. All right, so one side of the resistor to the other in ohms. $120K. So while that checks out, what I want to do is I want to test that 120K resistor from other places. So now what I'm going to do is I'm going to go to the two sides of the circuit as far out as I can get. So pin 2 of the, or pin whatever of the IC, pin whatever of the IC. So we put one probe here, and then I put the other probe up my ass. Okay, 3 pins in there from frequency in, so from filter in all the way over here. I'm going to then test random pin IC pin number, probably 7 or 8 or 9, whatever, this pin 9 maybe. I don't know. We'll have to get into this a little bit further. I think somebody had a suggestion for what this one was, and I think we had a candidate for it, didn't we? I don't know. Anyway, okay, so from that pin, from this pin here, you guys, can you see the mouse? No, you can't. From this pin here, and then all the way to the connector. What connector pin is that? Part of the slowness of this is that I got to bring you guys with me, which I enjoy doing, but it does take time. So 3 in here goes to, yeah, okay. Here. What the hell is this? Oh, there it is. $179. Oh, but that goes through the 120K. And if I go to, oh no, wait, it's this one. No, it's not. This one? No. Am I getting this right? Probably not. I need to double check. I'm being a big dumb. Okay. Big dumb. Check again. Hey, Celia. So we are this pin, and this image is the same orientation as what we're looking at. We go over to, we don't know what this is doing. Pin 3 is not what we want. This pin here, which goes through the capacitor. So we actually want, well, technically this side of the resistor will give us a full trace. If we go through the resistor, though, we'll want to check here. And I'll want that pin, the one with the stripe on it on the capacitor, to connect to the 3rd pin in 1, 2, 3, F in right there. And it is the same orientation that I'm holding the board out right now, so I shouldn't be too confused. You want it to be kind of definitive, because you don't want to leave it up to your... I don't want to be questioning yourself on this. This isn't right. Oh, it is flipped. Oh, okay, so if I flip it, then there we go. Okay, now I'm less confused. Okay, so I go from here to here. 120K. So that resistor is good. Oh, you guys can't see. 120K. So the resistor's fine. Could it be the capacitor? Let me see. If I go from the other side of the capacitor to pin 3. No, was it pin 2? It was pin 2. Okay, I get half an ohm. If I go to here, that's not going to give us a good reading. Well, it is charging. It does appear to be charging a capacitor. $6K. This, technically, I mean, it does have a capacitor meter, so if I do this, this thing is, what's the value on this? 50G. That's the voltage, isn't it? It says 686, so 6.8 ohms. 6.8, well, 6. 1.05 microfarad. 1 UF. With 50 volts, 1 UF. Yeah, chat's kind of quiet. We're doing a pretty good job so far, though. I'm cooking. I have so far, we've traced... I've got my delirious notes on the outside of this thing. We've narrowed down the performance of the TB303, and we figured out that, okay, hold on. We figured out that the VCO works, sort of. It probably needs a little bit of tuning, but the VCO, which is this section over here, works. Now, I can't speak to the specifics of what Acid Labs did in their design. It's not going to look exactly like this, but what I do know is a very similar looking waveform is coming out of that oscillator, and it does, in fact, go to a slider switch. And I took apart a slider switch to show you guys that all that they're made up of, slider switches and toggle switches alike, is just a piece of metal that contacts these things. So I'm like, wait a sec, I don't really know. Yeah, I know. I get a lot more done when everybody's quiet. The nicer ones of these will have some kind of like a puck of alloy material in there that'll reduce sparking and stuff. These are rated for 125 volts, but good Lord, I would not put that through these cheap Amazon switches. You want to get like a decent one from DigiKey if you're going to be putting like, you know, wall voltage through these things, because nobody wants a fire. These things are very, very, you know, they've made these very cheap to produce. But anyway, the point is, all this is a little bit of dielectric grease and a little rocker that goes back and forth. And the toggle switches are even worse. So I was kind of shocked that Roland would do that, but I guess they're cheap, right? We follow along or try to. I know it's like a big dump of information, and you guys are tasked with actually keeping up with me. So what we did is we put a square wave into the VCO as a control voltage, and the square wave controlled high frequency, low frequency, high frequency, low frequency. It's responding to that. So we know that it works. So now we're following the waveform from the VCO, and we're seeing what part of this doesn't work, because we tried a couple other things. We tried like the envelope and we tried the voltage controlled filter. It wasn't doing anything. So now we are tracing this voltage out. This is right along the lines of what I used to do, my old job. We would then, you know, we'd vet out these parts of the circuit like this while coming up with the schematic. And, you know, it would help if I came up with a full schematic, but still. Checking up on one new emergency stop switch costs for the CNC. Wanted to get the same one. They got real cheap, yeah. $97. Oh, well, yeah, if you buy one that's a reasonable price, it's going to be as cheap as this toggle switch here. It's going to be that bad. So we followed it out. We followed our waveform out, and we got to, dun, 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 this weird penis-looking drawing thing. And what that is a transistor ladder filter. In the same way that a transistor is NPN material, and you can diode test that NPN with N-type and P-type, which are holes in electrons. It has to do with how you dope the transistor, and that's not like the slang. That's like you add a doping material to your silicon, and it's a semiconductor. So depending on how you dope it, it'll make all these structures. Whatever, you can look up a physics book on your own, but the point is those transistors are NPN, so if you short two of the legs out, you're basically just making it into a diode. So there's a diode ladder filter and a transistor ladder filter, and they're similar construction, and they do similar stuff. So was the capacitor working? From what I understand, I get a 1 microfarad capacitor. I don't know what this 1/50th is here. 150? What does that mean? But I mean, in the same way, there's a resistor and a capacitor, and it seems like it's working, and it's going into whatever this unknown chip is. We don't know what this chip is. But it seems like we're going to have to figure out what this chip is, because this chip appears to be the next non-functional thing in our whole circuit. If I was able to get a probe onto this pin here, then I would probably see our waveform. That, or whatever's going on. We've got resistor with another one and a what's that doing? But then our same waveform is coming out and over to here, and we should test it here and see if it's here. Because if it is not here, didn't we test it here? We tested it somewhere on this run and we didn't see it properly. 1U 50 volt, 1/50. That is kind of strange. I like how seamlessly I just flipped over as if I didn't click on something that I thought was something else. That was way too smooth. I don't know. I don't think they're using the exact same values, because this is a 120K resistor. They're not going to be using the same value. The circuit structure being so similar is like a gift to us. But I don't know what these diodes, I think, are probably doing some kind of a, what is it called? Like a Schottky barrier filter, where you have a diode on the top of the bottom and your limiting voltages there, so that when you go off of those limiting voltages, you get flow through the Schottky diodes, and it limits the amount of input, so you don't blow everything up with a bad CV. Then again, damn it, that's the wrong scroll. Stop clicking that thing. Then again, so our waveform is still here. But if our waveform's there, that goes all the way out here, and it's got this big old thing right there. And it goes into another capacitor. Why would our waveform go in so many directions? Oh, because it's splitting it off. That's where our waveform comes from for some other output, maybe. Maybe. No, this is all power. This should be like 5 volts or something like that. So I don't know why that's running into our signal, which is for some reason here. Nope, it's not. I was just confused. Okay, hold on. Hold for dumb. So we're in our next stage. We're past the capacitor. Supposedly we have a signal here, although I haven't been able to pick up on it. That's what the X is for. So I've been able to pick up on this signal. I'm drawing on a notes layer right now, so I can just disable all of this stuff so I can see the original. We come over to here. And remember, we removed all these chips, so we know exactly what's going on underneath them. We left nothing up to chance. There and there. So there leads into another thing. And then there's another 1K that goes out to the diode thingy. So what do we see here? I mean, we should see some kind of a waveform here. Let's see if we can find this. Where is that? Oh God, it's in the sea of nothing. 1, 2, here and here, and we go up to, well, if we go up to the bar and then we go down the hill to the bar. Okay, so we go down the hill to the bar. So we go 1, 2, up to the hill, down from there to the bar. We'll do that when I plug this thing all back in. And we'll see what we pick up on. Also, hello, Uo's Lab. I saw you. I see you. I see you. I'm just explaining a lot. This is this is like completely in my wheelhouse, and I'm cooking right now. All right, so our landmarks. Turn this thing on, get our waveforms going. We gotta wait for them to come back down. There's something wrong. I don't know what's causing that. That's another thing to investigate. So we go, get this multimeter out of my way. Everything's in my way. I'm getting close to getting the resin printer working. I've just been a little reluctant to get it fully printing. I guess tomorrow I'm gonna do a little bit of cleanup under the other table back behind me, and maybe move some of the tools out to storage and some of the stuff I haven't been using. When we build the CNC, the POS CNC, I'm going to use that saw, which is, I got to be careful, because my dog isn't going to my brother's anytime soon, but that would be a good opportunity for me to use that saw. I have to put hearing protection on when I use that thing. It's going to be super loud and dangerous. But then I can actually start building up the CNC hardware. So here's one, here's two. I'll get you guys in here a little bit more. As you can see, in spite of all the stuff that I'm doing with EE, I'm so comfortable with it that I'm thinking about a lot of other stuff at the same time. It's how we work. So 1, 2 to the bar, down the hill. So this would be the one that we want to test. And we should see our waveform on here. Now, these vias have part of the solder mask on it. So if I twist a little bit, I don't want to go too hard into there because I don't want to break that completely. That looks like a supply voltage. It looks like a 5-volt supply voltage. I think something is getting confused along the line here. I think maybe our traces aren't what we think they are. Because we should absolutely be seeing a waveform here. A waveform to match our creepy looking square wave that we're generating out of the VCO. And I don't have the white wire plugged in. That thing's all the way over here. So this is not what we think it is. Because if we trace this one out, it'll lead us to a test point. And that test point is power. So if we come back over here. Oh, I guess this is a pull-up. Okay, so it's a 1K. Whoa, 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 whoa. Now I'm lost. Whoa, where's my mommy? Hello? Oh boy, we gotta go to the front desk. Or we can look aisle by aisle. We'll eventually, I think we'll find her. It's the scroll wheel on this thing is a little punch happy. Okay, so why does the scroll wheel go up and down? Somebody call mom. Call mom. This is real bad. It's real bad. Okay, so we're here, and this goes over to a 1K. So that's a pull-up. Stop moving. That's a pull-up. I gotta be careful of the scroll wheel with GIMP. GIMP, the scroll wheel, for some reason, moves you vertically. Why'd you guys do that? Make the scroll wheel zoom. That's what everybody does that. Scroll wheels always zoom. So our signal's on the other side of this resistor that we can't get to because remember, we can't get to this side of the board. We exist on the other side of the board. But if we go here to the little swoobledy-boobledy that's directly above the middle thingamabop, the little predator target, we go up a little bit from that one. And remember, this is 180 degrees when we look at it on the board, which I could flip the whole image 180 degrees. That would help us out a lot. Anyway, so middle here, and there's our shwoobly. And if I tap it right in there, we get a steady voltage level, which is moderately disturbing. Let's double check what was under the chip. Well, we can't double check. I didn't take pictures. I'd have to look at the VOD, which I do have a copy of. What day did we do that? I need to remember the date of when we did that in order to look at that. It's pretty clear what's going on. And I think it's that chat is doing this intentionally in order to make me look bad. And I don't take kindly to that sort of thing, chat. Why is that a steady voltage level if we are getting a signal? I mean, we definitely, where do we get a signal? Yeah, we definitely got a signal here on the other end of it before the resistor and the capacitor. We can't check to see if we get it after the capacitor. We did check the continuity on the capacitor, and it appears to be okay. We also checked the capacitor, going all the way back to Project Alpha's comment 10 minutes ago. The capacitor seems to be okay. We get 1 microfarad, which there is a big number 1 at the top of this cap and a 50-volt rating. So 1 microfarad through the multimeter. So by all means, I should trust that, but nothing when it gets to this chip. So maybe this chip is tanking it in some way, and the capacitor is kind of making up for it. The capacitor is like, whoa, 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 we'll isolate you from everybody else. Whereas this chip is going, we don't know what this chip is. I believe it was suggested to us by Ben Gizmo at some point, and we sort of, it's like the voltage controlled amplifier, I think, or it is just an amplifier. Is it just an amplifier? I need to get liquid. My voice is getting scratchy. I think my glucose level is kind of ridiculous. Let's check our glucose level. I don't even need to look at my phone to do that. I can look at the face cam, and then I can just enable this one, and that's the web page that tells it, okay, my glucose level is great. Let's see if it's actually updating. Yeah, it is. Hey, I ate a whole Wawa hoagie, and I guess they shrinkflated the amount of meat on the Wawa hoagie. The Wawa hoagie has gotten thin as of late. I noticed today. I took a bite out of it. I'm like, bread? And it was like, all bread. So my glucose level's good. I guess I'm just talking too much. I'm a little bit too much of a motor mouth. Although that's how streamers are, so we're going to be intolerable if Uwo actually gets to Philadelphia. Chip gets 12 volts. If that was flipped, it's toast. That's true. If it gets unfettered 12 volts, and I think it might, I offered to Dave to install diodes, and it didn't exactly get reverse voltage. It got plug in the wrong place voltage. So part of the circuit could have powered up, and part that wasn't supposed to get 12 volts might have gotten it. But then also it got me plug thing in wrong voltage. So me plug in wrong voltage, like me plug in wrong top board voltage. So who the hell knows what happened there, right? Tracing out this entire circuit while an academic exercise is also an exercise in us learning absolutely everything about the board, and maybe a little bit of what broke when things went absolutely sour. But this would appear to be the smoking gun. I mean, this chip is where our signal goes to die. We'll vet that out just a sec. Let me get my tea. And I have a big foam letter T. Oh, this stuff takes up so much of my time, and I really want to be working on some of the kitschy, fun things that we can do around here, like adding weird functionality to my stream and Node-RED. But again, you know, I'm trying my best to fix my friend's synthesizer here. TL074. Let's think about that. I will start a new layer. If this is a TL074, which they have censored from us before, that is a big dot. So just because I am made out of dumb, I look up TL074. With the amount of transistors in the next stage, I wouldn't be surprised if it was another 5 transistor thing. A newer version of this product, oh my god. Scroll, scroll, scroll. Okay, we gotta find the TL074 specific bin out. Why don't I just TLO? Put that in Google Images. Yeah, see, then you get this. This is easier for me to understand. I learned like this. I learned by viewing the chips like this. This is how I see them in my head. Yes, the smallest, most pixelated. Uh-huh. That looks great. Why am I getting a headache? Okay, hold on. Let's go over there, and now back to the second most pixelated image in the world. And then this layer that I just made, and then we have on pin 1, it's like this. And then this. Like this. Op amps are always annoying to draw. Like this. And we're just looking for the oop. Ah, son of a bitch. Undo cut layer. There we go. We're looking for the symmetry. We're looking for the connections of the diode, the stuff like this. And then we see that we have a signal coming in down here, shared with the output of another one, which that's a little strange. Output over here going over to a transistor. Sorry, it's a little jumpy when I skip around like that. I should probably use these. Output going up and over to there. And into this pin of the transistor ladder. And these are connected like that because the transistors are the 3 pins like that. They're kind of asymmetrical. No, they are symmetrical. Let's see. That would be the first one that we go into, being the first one that we come out of. But that makes sense because you would want to have an isolation on your very first input. You would want to use that first one in order to isolate things out. The only other part about that is that we don't have a lot of other componentry going into this. So we have a resistor capacitor. So the resistor lowers the potential amount of current that comes in. The capacitor simply centers it on the DC line, which makes it a good time to then put it into an amplifier. It would probably be a unity amplifier unless you really want to do specific stuff to it. That goes there and then to the next one. And this pin is the input. This one is the pluses are on the inside pins. So these would be the pluses here. And then from pin 1, we have plus here, minus here. Plus is going out and around to that structure. That one comes over here. That would put plus and minus on either side of a 1K. I'm not fully convinced. Welcome to the real engineering part, where Bother is almost entirely in his head, and he forgets that he has a, hey, make mistakes, how's it going? Inverting times 2, you don't think it looks like it? Sorry, I'm way in my head right now. The way that you would design something like this is you would have, like, if I'm plugging in an external signal, you would bring it in and then you would do stuff to it to make it not blow up your circuit. And one of the things that is commonly done is you put it into an op amp. Op amps can typically function from rail to rail. So as long as it's within the voltage rails of your system, it shouldn't blow up your whole life. But I'm not quite seeing a quad op amp, a TLO74, although it does appear as though it might be negative power here because, well, but then the output of one of the op amps is negative. It goes directly into negative power, unless this is a throwaway op amp, but we do have an external trace coming into it. Like we have a plus coming over here, and then we have a minus going out. So I think we've got a different, I think we've got an ASIC. I think. Now, was this the transconductance amplifier? Seeing as it's Pride Month. Let's undo all of our little squibbles here. This is squibbles to see if this is a TLO74, so we'll take this layer back to where it was. I thought this one was the weird one. This one was the transconductance amplifier. It's possible this could be another, I don't think this would be a quad Schmitt trigger. I don't know what that quad, the hex Schmitt trigger is, though. Are you still repairing the 3D printer? I don't have far to go with that 3D printer, to be honest. I need to get, oops, sorry. I need to get the carbon out of the little carbon filters that I did. I bought a 2-pack of carbon filters, and those things there. and then I put aquarium carbon in them because I thought that would be fine, but it's not, because air doesn't flow through that. Aquarium carbon is too ground up finely, so it all smashes together and it doesn't make like an air pathway. So I got to figure out how I would either make an air pathway, or I don't even know, or just use the carbon filters that came with it and assume that because it's constantly cycling air that it will remove a lot of those organic carbon whatever nonsense. I think the real thing that I'm going to do, I have a cheap Creality tent, and I'm going to take that cheap Creality tent, turn it on its side, and that makes a nice little booth where I can put the resin and I can put the alcohol bath that I'm going to need in order to run that printer. The surface of the printer, the actual print surface, hey NanoCat, how's it going? The surface of the print thing, the thing that gets lifted, is in terrible shape, and I think what I want to do is put that on the milling machine. I don't have a lot of amazing tools I don't have like a fly cutter, right, to make it completely. Yeah, you need an alcohol bath with resin printing, because what you do is you print by exposing the resin, and as you pull the resin up and away, there's still a bath of alcohol a bath of resin that print needs to get out of. So when your print is done, it's coated in unexposed resin. So you have to put it in an alcohol bath that cleans off all the unexposed resin from your print, and then you move it over to something that's going to expose it to ultraviolet for a while. So you can put it outside, you can put it in front of a plant lamp for a little bit, and then it'll solidify all the resin that's already partially solidified. It is messy. It's the thing that everybody tells you sucks about resin printing, but the detail on resin printing is insane. So I'm interested to see what the detail of this thing is going to be like. It kind of sucks, and that's what everybody complains about. But if I put it into a booth, you're supposed to filter the air, because there's some compounds in that resin that'll give you headaches, cancer, all kinds of fun stuff. But if you keep it inside of a thing that's like a sealed thing of air, then it shouldn't get too bad outside. Yeah, curing the agent resin is superimposed. Yeah, it's not amazing stuff. If you use it in little drops like I do to repair circuit boards, it's fine. It's fairly non-toxic. You can put it on your nails, get your nails did, make it seem nice and shiny. But if you have a tub of it sitting in your shop, spoiling all the air, you might want to filter your air. I saw comments on both ends of the bargain, though. There's some people that do computerized air systems that use all the pot growing technology. Actually, is really useful for resin printing, because those stoners know exactly how to put a lot of energy into something. They know how to move a lot of air, and they know how to make that air scrubbed clean. So all of those grow things for pot, you can even get them at police auctions if you really need to. If you want to start an aquarium, you can get the grow lights. If you want to start doing something that smells really bad, like curing paint and resin, you can get all of their fan equipment off of police auction websites. But you can use that equipment in order to move a lot of air and move it through a carbon filter. There's a company that makes stuff specifically for that, and it does a really good job. I could do that with the fume hood, or the whatever it is, the print tent that I have, but I could also just keep it its own air, like, not have too much external air exchange between the two. And I think I could use those little USB filters, and I think it would do just fine. We'll see. I mean, we'll see where we get with that. There are places that I need to go with that. And I think the first thing I need to do is clean off all the stuff that sits under this table. There's some stuff that I haven't touched in like 4 years that's sitting under here. The chop saw will become useful at some point, and it is kind of nice to have it sit there and look really nice and expensive. But I think I need to move a lot of this stuff out and away so that I clear out this underside, and I can put the printer, I can put the 3D printer, I could maybe put the synthesizer all down there. And then I can have blinking lights down here too. That's part of cleaning up this stuff too, is that I can get some of my bench equipment out here and show it off a little bit. What are you going to print to test it? I think I might do just a what is it called? Benchy. I might just do Benchy. Although it's not necessarily like a, well, I don't know. What do you print? What do you calibrate print? Looking forward to seeing the Goop printer go. I don't know if I'll be able to get like a specific, maybe I can set up OBS to do a time lapse or something. I don't know how to do that. But it's not going to be an amazingly fast Space Marine figurine. No, I don't really like chat. I don't really like 40K. I don't really like it. I don't know. I'm not a fan of space fascists. No, they're a good company. They're not like that. You got to get it right. Baby man is a fetish. Man baby is the toy. That's man baby toys, not baby man. We can't get that wrong. It's a slippery slope. Some people like NG the engine. Maybe I'll have to try that. Yes. Do a waterproof resin print of a laser jacket. Oh shit, I could probably do that. You're right. You're actually right. That's why I did the resin printer, because I wanted to further burn the subs. Yeah, that's why I did it. Yeah. Oh, you go fuck yourself. Well, Bodie McBoatface, or whatever it's called, Benchy, is built into the Lychee slicing software. So I might just do that. Okay, so what's my inspiration? What is this IC? This is the big question. I'm going to put that up on a little thing. Text. What doing? I'm going to make it called What Doing, and it's going to be ahead of everything else. And it's going to say, what is this IC? And the font size is going to be ridiculously tiny. Font, it's going to be all the way down here. With font, let's do like, no, hold on, let's do font 7. Okay. And we'll make that nice and big so we can read it. Oh God, I've gone too far. All right, a little bit larger than that. 16. We'll go a little larger than 16. We'll go to like 26. That's pretty good. That's pretty legible. Now, how do I get command of this again? There we go. I gotta find the little things that you grab. We have an IC that we do not know what it is. Why? What is? Chat, what is? What is this IC? What is this IC? How do we figure that out? What is the driving motivation behind this? How do we figure out what an unknown IC on our board is? This is something that the reverse engineer, of us, will run into quite often. And this is something that is sort of a, it's a staple of what I do. What do I win if I figure out what the IC is? There are those of us that already know what the IC is, and the only reason that, they may chime in if they already know what it is, because I think it is some kind of an ASIC. But, no, we do not have to destroy it. There are several dickbutt STLs. Why would you think that I would want to print out a dickbutt? I don't have anything that indicates that I would want to print out some kind of a dickbutt and put it on something like permanent. I don't want a permanent dickbutt around. I'm not a weirdo. Anyway, back to the circuit. So we got to figure out what this ASIC is, and we don't know what it is. What is this IC? We don't know. The place to start, well, of course, aside from your already built-in encyclopedic knowledge of every single IC that you've ever worked with. Now, some people are like that. We get all kinds. We get all kinds in here. Some people are freaks. They're freaks. And they kind of like already memorize everything. And I saw something on Twitter where it's like, there's always an engineer to be like, well, I would have done it differently. Like there's always an engineer that'll swoop in from on high. Oh, light comes down and they go, and they land next to you and they go, well, everybody knows it's a transistor. You're like, all right. So, what about the number on the IC? So here's the thing. We don't have a number. AcidLabs.de went through the trouble of sanding off their ICs, which is abhorrent. It's awful. So we have a sanded marking on top of this IC. Now, I don't need you guys to start throwing out pot shots. Please don't throw out pot shots. It might be a 2201, whatever that is. Remove the black stuff is the way that you would do it if you were like the government and trying to figure out what this IC is. But then you're faced with a die, and the die would look like die as in DIE, as in dielectric, not DYE as in die, as in the like some kind of a printing terminology, which, you know, chips are etched. So where did that go? We had a chip on here that was that gave us it showed us what the actual dielectric layout is, because they do that sometimes in these data sheets. They'll actually, yeah, here we go, here's one. So this is what the op-amp dielectric would look like from the top layer, and it would show you where the pins are connected. Why any self-respecting engineer would need this information is beyond my reckoning. I don't know why they'd include it, and they don't include it in a lot of different data sheets. But this is what the actual silicon looks like that powers a quad op amp. I don't need this. We don't need this. What we do in order to figure out what an unknown IC is we have to work with what we know. And what we know is what is connected to the pins, right? Maybe they're just embarrassed of their IC choices. No, they're trying to hide stuff from us. So starting with power, we need to figure out where power comes into this chip. And if we are lucky, it'll come in on unique pins. If this is a common type of chip for, you know, like you get common chips, you'll sometimes get power on the corners for like 7400 series and things like that. But if we can characterize what power is going into the chip, that's going to narrow things down significantly. We know the pin package, we know how many pins there are, and if we can figure out a couple pieces of information about what this thing is doing, we can help uncover either a family of functionality or something very specific about how it happens. I think I used to have that memorized in German. It's da da da. Yeah, so anyway, this is sort of the now part of this is also getting lucky. We're gonna get lucky, hopefully. And that'll uncover some other type of functionality, because sometimes you need the whole schematic in order to figure this out. I've had times where we would have a specific component that we wouldn't know what the value is. It's been knocked off, or we have an X-ray of the board. You guys want to know what I used to do? I used to reverse engineer IEDs, and they did not want us to know how these things functioned. There were a lot of commonalities to the function, so you get used to these circuits, and then you'd find something that's been anonymized in its chips. And so you look at where the power comes in on the chip. Every now and then, you'd find one that was completely unrecognizable, and you could make sort of infer kind of a guess based on the functionality of the entire rest of the circuit. Now, we know that we've got audio coming in, and we know that we have a voltage-controlled amplifier, and we know that we also have a diode ladder filter, well, transistor ladder filter. There should be a way to bypass that. I would think it would be some kind of an op-amp, but we also have in our heads, there's this transconductance amplifier. Free up storage space. Oh, hold on. Okay, to pause in my baffling rant about stuff nobody cares about, I just need to free up space really quick. So I need to go to my recording drive, and I need to scrape off a couple of these multi-gigabyte files and move them over to the storage thing. What's the date today? It's 6/4. These are from 3 and 4. So let's take only a couple of these just so we can free up. Well, actually, I need to free up enough space for one stream. So let's just take 2. And let's cut and paste those into the storage drive. Oh, and these would be streamed. I got to make sure they go into this folder. Otherwise, I'm going to be redoing. I'm going to be uploading them out of order. That should be a details view. Okay, there. So I'll free up space so my computer doesn't explode. I think OBS will stop recording if I'm not careful. And then all these memories will be lost to time. Like tears in the rain. Time to die. Okay, so what we need to do is we need to go back to this thing. I've been streaming for a long time, and every now and then something ends up on the desktop. So it creates a lot of e-waste. From what I understand, this one over here is a power line because it goes to a capacitor that goes to ground and it comes out of this chip here. And we know the LM317. We know the LM317. The LM317 is a voltage regulator, and it has a diode in one of the application circuits. So we know that this is going to be the output from the LM317 here, and it is on a convenient test point where we can actually pick up what that voltage is. So I need to do the extremely complicated task of measuring from the big test point here. It's like 5-ish, and actually it's listed there, isn't it? Is that 2 volt per div? Shouldn't I be getting a voltage reading out of that at the bottom of the screen there? Or remove that, does it go to 0? Yeah, okay, so that ain't 2 volts. Do I need to like drop a... I've got all this stuff on screen that I don't know what's going on. What's M? What are you? It's like a menu that, go away, go away. I don't need this. This is in the way. Oh, there, I just had to click next to it. It's like, what? You've activated the M menu. What do you want? Add a result. I'm poking the screen of my oscilloscope right now. Okay, get this out of here. Oh no, I don't want default. No. No. Oh, that's a click and drag. Wow. Okay, this go away. Well, actually, we can do measure. It's a button that it double pushed. Press measure once. Thank you. And then I guess Vmax, Vupper, or do I want Vbase, Vamp, Vaverage? Nah, that's too. I want like V local, like V for the last couple seconds. VRMS. I mean, Vaverage is probably correct. We could do Vaverage. So we'll have Vaverage on there for channel 4. Rid of that. And so the Vaverage at this test point, 5.7. No, 5.2. I was off by 0.01 volt. Yeah, so this is our 5 volt supply, and it's at about 5.2. That is a data point. All right, so let's take that over there. And so this is 5.2. Now, I guess we're taking our 5.2 as our half of 10. That might be what's going on. What's channel 1 and 3 looking at? Channel 1 is the yellow trace, and that is looking at the output from our function generator, which is making a 10 volt peak to peak, 20 hertz square wave. So that's positive 5, negative 5, and that's enough of an inducing voltage. That's going to 2 locations. That is going to our trigger input as well as our volt per octave input. Channel 2, blue trace. Is that really the blue trace? It's like the dark purple trace. Channel 2 is blue and it's not doing anything. Oh, channel 2 is our output from the entire system. So that is the main output of the M303. And it's doing nothing because it's broken. Channel 3 is the dark, I don't know what to call that color. Magenta? Is that a darker magenta? Is that what that is? I don't know what to call that. The red trace. It's not red, but red is harder to see. Magenta is just a little bit easier. Anyway, so that trace is telling us what the VCO output, only the VCO is outputting to that one. So we know that the VCO is outputting something. And then the last trace, the darker blue. I don't know what to call these colors. One's a light blue and the other's kind of like a different, it's like a more different blue. This one, the one that shows noise right now, That one is the probe pin. That one's the probe pin, but there's also a lighter version of that color that is the pin 2. I can change those colors. It's just what it is. Oh, and I guess the channels are labeled at the bottom there too. So that's 5 volts. So our 5 volts is coming around here, going into this cluster F of nonsense. Like a 4.7 pull down, 4.7K? No, 447K pull down, very weak pull down. And then a cluster of diode-y kind of stuff going on. Ground. But I mean, it's still pretty much 5.2 when it comes out here. That goes to 1 pull-up. Got a 1K and a 2201 is 2200, so 2.2K. Stuff's going on in here. That goes to that pin. 1K and a 2.2K separately, and then it's got that stuff in the middle there. I may need to put this to pen and paper at some point soon. Because that's our 5 volts coming in, and then it actually ducks down and over. It's not going to anything else over here. Yeah, it's not making any stops that we might not have seen. Those are definitely there. That's definitely there. Okay. Where's this thing getting power from? Yellow, teal, magenta, and blue. Blue and magenta are very difficult for me to differentiate from one another. Or no, not blue and magenta. Teal and blue. There we go. Teal and blue. Do a waterproof resin. Oh, I already read that. Yeah, I think the laser jacket could probably be done in waterproof. But then sealing it, I would use UV epoxy as well. So it'd be all the same stuff. So I guess then it would all expand and contract in exactly the same ways. I just don't know how the support material and stuff like that works in resin printing yet. I need to get familiar with it. So I need to print a couple things in resin. I don't want my first resin print to be the thing that dumps water on all of my multi-year effort projects. Where the hell are you getting power from? How can 5 volts get so close to this chip and then just so far away? All right, where's our 12 volts? I should probably mark off the 5.2 volts on like its own layer or something. That's for another day. 12 volts coming in from over here. So minus 12 is all the way down here. I have minus V. We'll use this scratch pad, and I'll just mark off. So negative V. Minus V. Those are all the G's, and then all my G's are right there. My plus V's are over here. Plus V goes 2 directions. Plus V. Going to whatever this one is. Goes up and down, and then it goes here. Ha ha! Wait, no, it doesn't. No, it doesn't. No, it really doesn't do that, does it? It does not do that at all. It just goes up to this chip here. So that's plus V. And then up to the capacitor where it goes from plus to minus. That one is specifically, look at that. So that chip is feeding directly from a power input. No wonder it's the first thing to die. Dead. So down we go. Down, 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 down on my belly. Scotch, scotch, scotch. And it skips this one and goes here. skips this one. I think this one of these it actually meets up with. I don't know which one it is. Because I think we have 4.7s or 47s or whatever on both positive and negative. Well, minus V comes down here. This is minus V. This one's also minus V. So minus V going to the negative of this one makes sense. Minus V takes a turn, goes down and around to this one. This one's minus V. I come down here. We got a minus V to ground capacitor, a decoupling. Minus V. Right there. And it only goes into that. All right. We are investigating. We are learning. Plus V. 0.33 pull-up. I'm shocked that it doesn't go into any of these, because that one goes from ground to here. It would seem like this one should be connected to positive V. It doesn't really look like it is. Well, what the heck else? Where else would it go? Maybe this sneaks under, goes like this. We just can't see under this thing. So yeah, that may be how it goes. We'll just put that on our scratch layer anyway. I have my room lights set to teal. So it's just like teal has a hint of green to it. I have trouble with yellow and green color blindness. I think it's probably because of diabetes and my capillaries in my eye being a little bit red. There might be a little bit of red in my optical goo. So I might see things with a bit more of a red to everything. I don't know. I have some trouble with that subtle yellow to green. I've had trouble with this. My friend and I playing Dreamcast, and we're playing some arcade game, and he's like, you're supposed to go for yellow, and I'm like, I don't see it. I don't know what it is. I can't see anything. So negative voltage. Takes a turn over there. Ah! It skips around because I hit the scroll wheel. Someone mentioned Dreamcast. Yeah, the greatest console. Oh, negative voltage also comes over here. Minus V. It's here, and then this one is minus V. And we're going up and over. Oh God, I have to get the scroll wheel divorced from the scroll up and down. Minus V. Play games with color correction enabled to make seeing players easier. I say green when it's really blue. Have to remember what things are colored in normal mode. Yeah, it sounds very confusing. We don't know what's going on under the caps. I haven't fully vetted that out, so now we don't know if any of the stuff exiting this cluster is another chain in our minus V saga. There's 2 test points over here, though. Those look pretty significant. Plus V, and this is supposed to be on the underside of the board. I just labeled it wrong. Coming over here to this juncture here. So label that plus V. And then that makes this the plus V test point. This really seems like it would be a minus V test point or something, but it doesn't, I guess it doesn't. That's weird. Are they just jumping plus V across? So this is also plus V. What is this? Why is there a big old stanky test point right there? Oh, we might be some other kind of voltage regulator. I hate that I middle click to drag. Hey, Poopsie Doodle. Right now, I am mad because what I'm doing is I am center clicking and dragging around the board. Because center click in CAD and stuff like that, you know, typically is your hold on to something and move it, right? When I let go of that, because of the nature of the SteelSeries mouse, it'll sometimes click over a notch on the scroll wheel. When it does that, GIMP is like, oh, you want to move vertically or yeah, well, basically vertically. You want to move vertically, so it'll jump me vertically up and down. It's very unsmooth. See right there, it just did it. Center click, drag, let go. Okay, there, we made it. But I'm clicking around so manically right now that it's hard to be careful. So this one would be -V. So far, we have not gotten near where we're trying to look. We are trying to look for this circuit right here. We're trying to figure out what this one is. And so I'm trying to trace the power and the ground into it to figure out if we can get any insights out of that. We have 5.2 volts coming in here. Let me put a plus in front of that, just so it's more visible. 5.2 volts coming in here, but it comes all the way under the chip, doesn't associate with it at all. Just two ships in the night. So, where is Pooter? Where's Pooter? Where are you getting, Pooter? Oh, if I control click, I can do this. A really low frame rate zoom. Dun, dun, dun. All right, enough of that. Jeez. -V, down and over. What? Did this turn into... It's actually, this is a +V. I'm working on a separate layer so that I can undo the scratches if I need to. This is just a scratch pad. We're just kind of looking at what stuff does. We would have done a stream where I turn this into a schematic. I think I should do that with Fusion 360 so that when I'm finished with the schematic, I actually have like a design that I could make, even though it is stolen. I don't know, maybe. But what is, yeah, have you gotten the synthesizer to synthesize? What we're doing is we are tracing down the functionality of this thing. So I have traced signals through this, and I know where our main wave, we start at the VCO, right? Because that's how this thing is. It's a series of events that'll end up in synthesized town. And this TB303 is a couple different things well, the M303 is a couple of different things in a single trench coat. It is a voltage-controlled oscillator, so the wave starts there. It is a voltage-controlled filter, so the wave gets manipulated. Then it is a voltage-controlled amplifier, where the wave gets amplified. And then at the end, or amplified or unamplified, I don't know, whatever, tamped. And then it also has some kind of an envelope trigger. And we have traced our waveform through the front panel all the way back to this one chip over here. So our waveform is being created, albeit a little bit sloppy. There may be some things that need to be kind of corrected over where it's creating the waveform. The waveform kind of starts at a weird spot and charges down. It's not necessarily what should be happening, but we've traced it all the way to this area right here where we ohmed out with the multimeter the screen moving around. Controls. Where's controls? Preferences. I'm getting real mad at this thing. Why do I need multiple controls to move me around? Dockable toolbox. No. Edit. Keyboard shortcuts. What is it? It's movement, right? File, context, debug, help, edit, view. Scroll up and down. Scroll page up. No, but there's nothing. It says disabled, so. There's all shift and there's no like center wheel scroll. Of course. Whatever. I don't have time for this. The first IC before the filter stage. That's, yeah, because we have the transistor ladder filter is right here. And we know this is a BC847 bullshit, BS. So we know it's a BC847. We know it's in a ladder configuration, and we know that these two pins are connected, which makes it, according to the TB303 schematic, which they are following very closely indeed. We don't have a schematic. We have a schematic of the thing that they designed this off of. And the thing that they designed, all right, the thing that they designed this off of has this penile looking thing right here, which would be all of our BC whatevers. But we have a lot of transistors in this area, like a lot. It would stand to reason that this might be another one of those matched transistory guys, where you have 5 transistors in one package. Xbox's RE303 and several TB303 cones. This is an M303. This is the modular version of Acid Labs 303. And we've gone to the trouble of taking pictures of the front and back because they had the audacity, they had the audacity to cover over their transistors. Now, yes, I know what these are. These are a pair of transistors. I don't know. The BC847 is a pair of transistors. Yeah, these are, Sid Heresy is more famous than me. Who is this person? Oh, a modular guru. Yeah, so for the benefit of the people in the back who don't know what the hell's going on, I'm going through this comprehensively. We had somebody tip us off to one of the ASICs on here, and we also had, who was it? It was, well, one of the other viewers told us about the notes that actually Acid Labs has in order to repair these modular synthesizers. When somebody plugs them in wrong, there are common explosive elements on this thing. So we have the benefit of those elements being called out to us. But during the testing phase of this thing, when I still didn't quite know that there were specific components to replace, I tried to attach flat cables from the front and the back so that I could probe around inside of this thing, because we have a very simple test setup, and I connected them wrong. So I think I actually blew up some extra stuff. So we got to go through it and just figure it out. And this is also, it's teaching me and it's teaching chat how these things work. Yeah, very simple test setup. You see over here, we've got an H connection with multiple ins and outs. We have our scope connected to our frequency generator, and we have the output of the frequency generator and the scope going to the input. And then we have another thing monitoring one thing, and then we have that over, and over there's power's over there, and then it's a mess. But we're getting into it. We are getting into it. We're figuring out exactly what's going on these circuit boards. In order to figure out a lot of what was going on with no knowledge, without all of the synthesizer gurus in chat that appear to be finding my chat all of a sudden, where were you guys? Where were you guys when the walls fell? I've taken comprehensive photos of the top and the bottom of this thing because I used to reverse engineer IEDs. They were disarmed, and well, they were recovered, disarmed, and then FedExed to the FBI, where I would then don a pair of white gloves, take pictures of the front and back, and get to work reverse engineering the circuit. Now, there was a lot of institutional knowledge about how things worked, but the most interesting circuits to us were the ones that we didn't know anything about. And since this is mostly, well, yeah, this is analog electronics, this thing has been a treasure trove of interesting circuit, well, not design. The design is fairly straightforward. These are Germans making the board. But it's been a treasure trove of analog circuitry that we can take a look at. Now, yes, Acid Labs went through the trouble of sanding several of their ICs down in order to keep the average consumer from knowing what was going on, which probably seemed like a great idea, but then again, to them, this cable right here as a power input seemed like a great idea too. This is a 10-pin, or no, sorry, a 14-pin IDC cable that allows you to plug it in off-index. So you can plug it in off-index, and there's no repercussions, except that people kept blowing these up. You're supposed to plug it in like this, offset by 2 pins, so that the first row of pins on the inner connector is connected to the stripe pin, which is -12. There is no way to know that it should be plugged in this way. There are no indicators. There are no markings. There is no keyway. And it's bonkers crazy, you know, go nuts. If you plug it in like this, it destroys some of the circuit elements. There are no diodes on here. There should be diodes. There should be, I mean, for all intents and purposes, that right there is space to put a keyed connector. And that's what it should have been. That's what that space should have been used for. Put a 10-pin keyed connector. The purpose of these is that these daisy chain Acid Labs devices. So if you're daisy chaining Acid Lab devices, you go in this one, out the other. And I guess you have to be an electrical engineer and or read the documentation with a microscope in order to figure out that stuff. Yeah, shotkeys are cheap and they're going to protect the rest of your circuit. I will never build something without shotkeys. I'll probably eventually put my VCO design on GitHub, because I don't know how Sid, you've been around before, right? I've seen you here before. I don't know. I've been doing a lot of this synth stuff, and the gurus come and go, but it would be cool. This is a Hajiwo design mixed with mutable instruments circuit elements, and so it's a VCO that uses a Sallen-Key filter. I lurk a lot. Yeah, because I've recognized the name. I clicked on your name and it was all modular synthesizer pictures, so I'm like, is this person famous? But yeah, I want to put these designs online so other people can make them, because I'd be jazzed at other people using my designs. Because this is Hajiwo / mutables. Mixed by Obother. And then a Chord VCO that looks a lot cooler on camera, but we'll get that one done later. I'll get Julian and Dave in here eventually. Maybe I'll fix Dave's synthesizer. That's a pipe dream. So anyway, we're trying to figure out what these components do. So we're kind of deep into it suddenly. Oh, we're on at the same time, yeah. So you have no knowledge of the people who fill the same time slot as you. Streaming is such a strange thing. So everybody here, go check out Sid Heresy and leave me without any viewers. It would be my honor. Yeah, transistor ladder design, and they're using special little ICs that they selected. I mean, they went through the trouble of finding what IC would make a 303, make that acid house sound out of a transistor ladder filter. So I mean, Acid Labs deserves some credit, but we're still kind of miffed that they sanded off our ICs. So that's what we're trying to figure out. We have traced the VCO, dirty though it may be, from down here through the front panel to this chip. That's what happens next. The VCA, we have not, I think this chip over here is one of those transconductance amplifiers. I think we were tipped off about this one being a transconductance amplifier. And it might have been you, it might have been somebody. Ben Gizmo is who told me the PDF with all the stuff in it. Yeah, this is the transconductance amplifier. This is the VCA right here. Let me get my light. Okay. This is my light. LM13700. Yeah, that's it. I think it was you, Sid, or somebody else told me about the LM170 whatever 100 when we were trying to figure it out. The work phone beckons with other people's problems. Oh man, go do your work. Do your work, chat. Don't let me distract you from that. Yeah, so the LM13700M, apparently a lot of people know about this. I don't. I have no idea what it is. But it's a voltage-controlled amplifier. So we know that roughly this block of circuitry and the TL074 over here, that would be our output section. So this is our VCA, voltage-controlled amplifier. But we have traced our signal all the way to this, which is the, I don't know. I was thinking that this would be a TL074. That would make a lot of sense. We have certain pins that are doing certain things on this thing, TL074Ys, but it doesn't make a ton of sense. But over here, we've got our transistor ladder filter. But this is 246 transistors, and according to the schematic, we have about 10 billion transistors in this area of the TB303. This is the TB303 schematic from their, whatever it is, the repair page. And we've got 250,000. 6 transistors would make up the amount of matched pairs that we have. And those individually matched pairs, I don't know if that, does the BC whatever, John? Does this John do this, John? What is this, John? The BC847BS, John. BC847, we don't have that up yet. BC847 data sheet. So like reverse engineering pretty much goes like this. We can go in and we can go forest for the trees. We can find the functionality and trace it. We're trying to repair something, which is why we're doing that. We could also go in and just one for one recreate the schematics as they are and look at something that does a similar job. So you would look up something that does a similar job, and in this case it's the TB303 that does the similar job, and that would influence how we draw our schematics. I have a much clearer schematic style than Roland does. My schematics are structured from in to out on left to right. So I would restructure the schematic a little bit to represent that, and then I'd probably need to look up a little bit about what the parts of this thing are doing in order to arrange it to be just a little bit more clearer. Because what Roland also does is they move all of the functionality, all the adjustments and stuff out here. So I wouldn't do that. I would keep them in with the circuit and just label them very clearly. What did I do, Animal Groin? What happened? Who collided? I thought you were from Adam. Where are you from, Adam? I don't think that any of the slightly furry names were from my fanage of other people's streams. So, okay, over here, you know, we've found that a lot of the functionality is very similar between a lot of the different areas. Like we can find these signals throughout, even though ours are moving around and they're a little bit janky. So I'm assuming, and especially over here where they decide to switch between waveforms by just using a slider toggle switch, which seems like a really dirty way to do it, but I guess it works. So we've been tracing that, and we found that it stops at a particular area, and we run into the transistor ladder filter. Now this is the wrong part. BC847, but is there more information to it than that? 847BS is probably the package. So I want to add BS to it. There she blows. Dual NPN small signal surface mount transistor. Nobody said super matched. VCOs of greater than 45 volts. Ultra small surface mount, ideally suited for automated insertion. Aren't we all? For switching as fuck amplifier application, totally lead free, halogen antimony free. Why is this antimony? What the fuck is going on with these things? Automotive applications requiring specific change control. Nope. None of these appear. I mean, fine. That's all well and good. Nothing indicates that this is a matched pair. I mean, one would assume, but every time you assume, you me. So EB voltage of 6. Those are the curves. Very curvy, looking nice. And no further. It's a 5-page data sheet. I don't see any indicator that these are super matched. Exotic vid poll. What? Garbanzo beans. I don't see nothing. Like there's nothing that indicates that these are super matched. These are just 2 transistors in 1 cup. And yeah, there's nothing going on. And the symbol for that, if we were a supermatched transistor pair, supermatched just means that their specs are like in lockstep with one another, and they're good for circuits like this, and that's what that circle around it would mean. Now, if this is the other component that we already replaced, I mean, I guess you could consider them to be thermally coupled. I don't know if it specifically is. It looks like the connections here are a little... Maybe they use canned transistors for this, but yeah, so as far as we can tell, oh, look, I'm being very specific. I'm covering all my bases because people will find every single, you know, unwatertight seal. The words do not come easy at this point. Okay, anyway, I can't talk. My brain it's melting. The LM3045 we are getting unfortunately familiar with, which is 5 transistors in a frock that are actually matched with one another. So these 5 share properties. Why 5? I don't know. I actually don't know why 5, why not 6. Maybe just because this is a very easy package to put a bunch of stuff into. Why the 5th? I plead it, but I don't know it. But this is this what we have in this part of the circuit? There would be no power in to this. This is where we give up tracing power because we're in a section that, well, something, no, you have no power here. Yeah, so maybe we don't need external power in this section of the circuit, and that's why I haven't been able to penetrate this area with my pluses and my minuses. We got 5.2 volts that comes in and skirts by and doesn't actually touch any other part of the circuit, and then our pluses and our minus seem to run out, although there's probably a couple more places that they go to that I haven't quite vetted out yet. Let's continue to trace. What was this one? What was you? Oh, that's our signal. No, that's not our minus V. Minus V is, what's going on there? Minus V going up and around, and I don't know if there's a via or it goes under. Well, if it goes under, it pops back under over there, so look at our other layer. So these are the photos that I took using the microscope. Yeah, so that doesn't actually touch minus V. Minus V is that a via right there? This is why we try as hard as we can to work in multiple layers. Yeah, there's no via there. So let's erase that. How do I erase? Why do you work so differently from everything else? So which one is the minus V? That's this here, and it goes on the top side of the board. Up, over, and potentially to that pin and over to here. So I'm gonna actually circle that with the pin. I'll put an arrow on it. That'll make it a little bit more clear. Okay, that's a little, I don't know what's going on there, but our minus V up and over, down, okay, and then it goes into the question mark zone. And then our other signals that we have here, we've got minus V, plus V, plus V, plus V's going to there. This one's plus V. Up to here, mark that as plus V. This will just help me reverse engineer the circuit later if it comes down to that, and it appears like it probably will. Plus V there. A question mark chip was probably a decoupling capacitor that wasn't needed. V there, plus V here. This just helps me know what's what. And if you know what is what, but you don't know what is what, plus V, you can see plus V is hitting a lot of these decoupling capacitors that have a ground right next to it too. Decoupling capacitor is a 0.1 UF capacitor that you put in there, 0.1 microfarad capacitor that you put in there as sort of a first stop for your power. So as your power is traveling along your wires, it'll hit that decoupling capacitor at time equals 0 at the millisecond. You got to think in terms of like outside of human perception. But at the millisecond that you turn on your machine, all of those wires and stuff do not have electrons in them yet. And as those electrons build up, there's going to be like a push-pull. There's going to be all kinds of like weird noise and stuff, like filling the pipes up with water. The pipe analogy always comes up, and I hate it, but it's necessary. Weird stuff's going to happen. So these decoupling capacitors at time equals 0 are uncharged, which means they'll act like a short circuit in a DC circuit operation. So as the short circuit, as the power's coming up here all weird, it will be then short to ground until it charges that very low value capacitor, 0.1 UF. Not the smallest, but it's not the largest either. So this one's plus V here. And now we know where our plus and our minus are coming into this chip. Plus and minus coming in at the center speaks of it being a 74074 or whatever, an op amp. Yeah, inrush current, and then any other kind of foibles that the power supply might put on the line, which is usually not much. But the 0.1 UFs are there to keep the chip power clean and everything, you know, come up to power all at once in the chip. Chip by chip, it's going to vary, but like for instance with microcontrollers, if you're coming up to power in those milliseconds, you could have one part of the chip come up to a functional power, whereas another part of the chip isn't there yet. And so things will start turning on at different times. So if you have that capacitor there, everything, boom, gets power and everybody starts functioning at the same time. It just avoids some like early onset issues that happened with these kinds of things. Are really those both connected? And I guess that one isn't. Okay, so where are we? We are tracing out our positive voltage and we're right here where it branched out. So it went 3 directions. One of them came up here, so plus V. I think marking it at the V seems to be the most logical way to do this. This one is now plus V. Aha. That's different. So that going up to these two is positive. That one was our signal, wasn't it? I should probably have marked down what all these junctions are. Yeah, this one's our square. And then, or no, that's not our square. Hold on a minute. There. This one's our square. This one's our square. It's actually square / triangle, but so that's coming down over here. Okay, that's not interacting with it. That's a totally different part of the circuit. Holy heck. There, and there. Uh-oh, I think my dog just got in trouble. Heard the full name being mentioned. All that said, I don't know. So let's go from pin 1 and let's figure out what this IC is. So I start another scratch pad layer. Let's do one on top of this thing. And let's get rid of this, or the one that has the marking there. And I'll try to draw transistors on top of this and see if it makes any sense. Because it really doesn't look like we've got power and ground going directly into this thing. Oh yeah. Is this more powerful than the, or more complicated than the LED circuits? The LED circuits involved coding, and so I had to know what my program was doing at certain points in time and code around that. I still haven't fixed those, so I'll have to go back into programming mode and finish this. Did you say it didn't have power rails? Not going to this. Yeah, I don't see power rails on this chip necessarily. I don't know if I see ground yet. We've been tracing V-, we have not been tracing ground. Oh, IED. I can't speak on that. Things got very advanced, and things got very analog, and things got very digital, and things got... I can't give you like a... I won't be able to give you a solid answer on that, no. All right, so if this is a 5-transistor circuit, that's what I'm saying. Like, we've got 3 transistors here, assuming those aren't diodes, right? The 3 SOT23s. We've got 246 up here. There should be a lot more. There should be way more transistors. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And our OG circuit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I could probably easily just find 14 hanging out. Yeah, there's 14, 15, 16, 17. We need something like 17 transistors to do it this way, exactly this way. So you've been working on the synths for a while. I have a serious question. Name 2 songs. One your current favorite and one your guilty pleasure. Oh, you don't want to know. I haven't been listening to a lot of music lately. We do have a music channel on Discord. You can see the commonality of the things that I normally post. You just search by Oh Bother, and it's going to be a lot of the same posts over and over again. So the guilty pleasure is probably going to be the one that Felix Colgrave animated. And then the current favorite is a very tough one for me to figure out. I haven't been listening to a lot of music lately. That's a really tough one. Wonky Robot has Pizza. Hell yeah. Current favorite is a very difficult one to pick out. The problem is I watched like all this like modern YouTuber turned actual TV show creator stuff, and now all those songs are stuck in my head. Feed him more music. Don't feed me more music. Ciano had a lot of very interesting music too to share. It was, yeah, it's pretty cool. There's a lot of worlds in music that I don't know about. And I know a friend of mine is getting back into that old school 2000s, early 2000s EDM, which is dangerous. Yeah, the transistor package is the LM 3045. What they used to have on these things is an, oh God, what is it? I've got a couple analog. I was hoping we'd get to more than just this today, because I have more than just this to work on. We need to get that LED blinking, and then I've got a couple analog synthesizers here that I need to get working again. That's why we're doing synthesizer stuff every now and then. You've returned from BS. How's it going? We're getting there. We're getting more and more information about this circuit, and we're kind of tracing down the functionality. This one is one that I have to fix. I have to come up with a better way to do this. This specific synthesizer that I was working on is the Bic and Tick filter, and it has sort of that dual transistor VCO built into it with a filter. And what I did is I bought it in the wrong size, and then I snapped it over my leg. So now I need to repair the circuit. I think I should do this with motor wire. Dr. Plugger, thank you so much for the sub. But what these have is the, what is this? AS394H. This can, with a little temperature compensating thing, yeah, this one is rough. I can't wait to get this one working, and I should by all means have gotten it working, but this wiring is killing me. What I'm going to do is probably take like solid motor wire, maybe something smaller and more compactable than this stuff, and make it a little bit better. But snapping it over my leg was the important part. Oh, Sid's getting a kick of that, yeah. So what this has is this has a super matched transistor pair, and you can also get this in a dip socket, and then a temperature compensating thing. Now, what the replacement for this, because these aren't really available anymore. You'll notice that I bought a can. That can was like $15. It's ridiculous, right? You have to get these from like audio websites. So instead of this thing with the Temco on it, you can go to RF stuff, because RF stuff still needs to make a voltage controlled oscillation, right? Although now they have temperature compensated and TCXO and TCTO, all kinds of like RF stuff is great. You got a lot of really good stuff. But so instead of that supermatched transistor pair, the LM3045 has 5 matched pairs. It's more of an RF kind of transistor. But that means that you get a bunch of these in one package. So the question is that what we've got on this transistor ladder filter? It would seem like probably a good idea, because you've got at least 2 pair in one chip, right? And if that's the case, then our pin 1 being over there, and I've started a new layer so I can just jot this down. I can just come in here and I can go from pin 1. There would be a transistor here. Hold on, let's see if we can do this a little bit less. That goes to this pin. And specifically because one YouTube comment pointed it out, I am going to call these that little arrow leg right there. The leg with the arrow on it, the little pointy arrowy guy. And then we have this pair here. So this one would come from here up and around. You draw it like this. It's going to be a little bit weird. This is going to be very sloppy. Oh yeah, it should be centered on these, but whatever. So there, that one with an arrow. We don't have a lot of pixels here, so I'm going to draw this in kind of a really terrible way. But you know, it's good enough. That's fine. Be another transistor, and then from here we would have this one going like this, like that. Oh, it's too close. I could probably just cut and paste the entire picture of the chip. I could just cut and paste the like datasheet image, and it would look a lot better than what I'm doing right now. But this is specifically to torture the people watching the show, so. Like that. It's as clear as mud right now, but we will take a look at the individual. Yeah, KiCad or doing it in Fusion. In Fusion, I'd have to choose parts for everything, and I don't have parts chosen for everything. So, I mean, but in Fusion, you could have placeholders, and then you could jump over. The photo ID is something that I've been doing for years. It really helps, and then you can do multi-layer image editing, multi-track drifting, and it helps you kind of just get everything down on a page. This is when I was at my most ADHD, because you'll start out the circuit and you'll start jotting down like a specific area, and you're like, wait, is that there? And then blah, blah, blah. And you have like 4 or 5 sketches for the thing. So what helps in order to keep you from continually resketching it is to do a photo with all the stuff jotted down, and then you can boil this down to individual areas of connection. So I'm working on this. This connects here, this connects here, this connects here. And you put that into your CAD software. From there, you know that those nodes are as they are. So if you need to split them apart or move them, or yeah, it just helps you kind of move through the process. The way you do it without doing this is you do multiple different sketches of the schematic, and it helps to take a second sketch and a third sketch. So you get everything down, you get all your connections down, and then you organize it in the next one. And then you organize it again in the next one. I've sometimes done this several revisions deep. Whew. I've been gibbering out here. I've been talking at 1,000 miles a second. So then the question is, when our signal comes in, does it come in on a relevant pin? Because we don't have power coming in. What we expect to have happen, and so far it has, is that from the schematic of this thing, I should probably have another paint document for this. This one is already pretty well labeled though. Coming out of that switch, we are right here, where there are both triangle and square. Triangle and square comes down to a resistor. Ours is half of the value of this one. It's almost half of it, 120 instead of 220. And then we have a capacitor. We do have a polar capacitor in the path. They have a weird symbol for polar capacitors. I'm not used to it. And then we come into some other BS over here, some other BS down here, some of this over here, and we go directly into the base of a transistor that is a matched pair. So we have, coming into here, there's our 120, there's our 1 microfarad capacitor. We come in to 2 different locations. One of them is the base of a transistor that is part of a matched pair. That connection makes sense. So, and it also goes off to a bunch of other bullshit, which includes a pull-up, a 2.2K to a pull-up to 1K to some other BS. Now, is that literally what we have in the other schematic? I think this is more literal a thing than we thought it would be. Capacitor to ground. We have some other source here. Circle with a line through it going to a 2.2K. Well, it's a 1K, and that one's a 2.2K. And circle with a line through it might be 5 volts. So we might be our smoking gun. We might have figured out what this thing is. Dear God, this is an obnoxious part of the circuit, though. This is an obnoxious part of the circuit. So is that what this is? I mean, we need to know definitively before we go in and replace it. But it could stand to reason that I blew up some transistors in here when I hooked things up wrong. What is the other end of the supermatched pair doing? Well, one of the other ones of the supermatched pair goes to a pair of non-supermatched transistors, Q13 and Q15, and then it's got that capacitor in between them, and then the base of the other one is coming from 2.2, 10K. God, these circuits are so... we tried to build one on the perf board, or on the breadboard, and it did not work out. I think that's mostly down to my resistors being terrible. And I've got like a hand soldered Hajiwo circuit that I've been trying to get working. Okay, so we come in from the capacitor over here. We go to the base of this one that goes two different locations. One of them never follow a transistor to a second location. One of them comes down here and to a 2.2. That would be the emitter. And that is the emitter here going to a 2.2 to another transistor, which is another transistor. It's sitting external. What about the... Well, that would also go to a second one. This is on the wrong side of the 2.2, and that would be, it would actually be the emitter. So this one and this one, which if you can't see the mouse, it's here and here. And those would be matched, assuming, but then that would go through the 2.2. Possibly not, well, oh, wait a minute, through this 2.2, R70. Oh no, that's base to base. Wait, ace to ace. Ace to ace would be here. That pin, ace to emitter. The mouse is showing up. Okay, good. Oh, it's the second location. The OG power supply is ridiculous. They use an op amp to take the 5.33 volt rail up to 12 volts. Oh, because it was a battery operated device. Yeah. That's crazy. They were making 12 volts. I wish I had held on to some of the weird stuff that we bought back in the early 2000s. Because we'd go into the music stores and they'd be like, we got this weird thing. And they'd have this weird battery powered like sequencer. And I was like, dude, I should have held on to that. It would have been like the perfect kind of thing. And that poor op amp. I mean, it should be emitter to emitter, which would be this one right here. That one connects to this pin, goes up and over to the one of the transistors of the ladder filter. And I don't know if this is the upper or the lower. I guess it would make sense if the base of the whole thing, the bottom of the whole thing was over here. But our signal comes in through this area, and it goes to this transistor here. We're still under the assumption that this is a transistor circuit, but we don't know yet. So we come in, and we go to this one here, Q12. The opposite side of Q12 is which one? It could be any of the ones inside of this thing. So what would happen is that the emitter here goes over to another emitter. So theoretically, this emitter here, this pin right here, would go to this pin right here. And I know my schematics are extremely sloppy, but it looks like this emitter here goes up and down to here, and it goes out to other stuff, which is a little bit odd to me. I don't think I'm turned, oh, am I turned around? I might be turned around. I might have turned this whole thing around. I might actually be turned around. Hold on a second. There's hope. There's hope. There's a glimmer of hope. This horrible, hopeless world, there might just be a data sheet where I've reversed everything by accident. Yes, I did reverse everything. That makes it even more of a case. So actually, instead of what we have, actually bother. There are probably keyboard shortcuts to do all this kind of stuff. I'd hunt around for the thing. Where is my twisty doodle? Twisted doodle. Where are you? Transform function. Twist! Activate! Yoink. Like that. Select none. Select nothing. Wait, none isn't even usable, but yet, oh, I see the floating selection. I hate that part. I have to, in the layer menu, I've hidden away from you. And in the layer menu, there's like a finalize what you're doing. Yeah, all right. So that looks terrible now that it's been rotated, but at least we know what's where. God, it looks awful. So that means that our signal coming in is coming in squiggle, 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 squiggle. This would be the input here. Let's put that on the layer with the rest of the squiggles. It's that one. Oh, that's not the right tool. Escape. Don't alter anything. Go back to pencil. That's there. This is here. This one is our squiggle. Okay, and then that's where it goes to die. Okay, so if our squiggle's coming in here and it goes to this pin is connected to, and then that is still the base. The collector's over here. We have a dual emitter that then goes to a 2.2K. This is looking very familiar. So I'm going a mile a minute. I'm gibbering. I'm having an out of body experience. Everything is weird. We've got the taste of lead in our mouths, and we're a little bit disoriented. But from what we're seeing over here, these are extraordinarily similar. I mean, on the two supermatch transistor pair, we have a 2.2 2201. So that's 220 with 10 after it. 2200, 2.2K going into some part of the transistor. If we remember, these transistors are unfair in the way that they're presented. This may look like the symbol for a transistor, but that's not how they're oriented. And it's mostly, I think the reason they do that is because it helps with layout. It helps the layout when you have to put a resistor from emitter to base or whatever. So anyway, but the point is, it is going into another TO223, SOT223. Anybody else smell toast? Starting to smell a little bit of, what the hell was I doing right here? What is going on there? That's totally confusing. There was some other thing that I marked down right there that's very, very, oh, I see. It's because this is still there. Yeah, we don't need that up right now. So yeah, our signal's coming in here. It's going over to here, and it goes to just the base of one of these transistors. Now, the shared output goes to a 2.2 that goes to another transistor. The other side of that, that's not the other side of that. The base of the one on the other side of that goes over to, oh, Lord knows, a lot of complicated stuff that I don't know what it's doing. I haven't learned anything about this part of the circuit yet. I'm starting to really think that this is what the circuit is. I'm starting to think that it's actually this 5 transistor thing, which we know blows up. What was that? Something just popped up. YouTube is not receiving enough video to maintain smooth streaming. Uh-oh. Why obfuscate the match transistors? When was that? I don't have Wonky Robot. I'm so sorry if I missed that comment. I think it was a while ago, but why obfuscate? I don't know. Maybe that's their special sauce. They figured out exactly what complicated. Jeez. All right, fine. I'll laugh at it. What is keeping this thing from streaming? Is it a bitrate thing, or what's going on here? I freed up some space. Oh, it looks fine on YouTube? Yeah, it just popped up with that. I don't know if maybe... Oh, I don't have the social stream dashboard up. That's my fault. I didn't put that up. I was relying on other sources in order to see what you guys is talking about. Now I can see how long ago the Wonky Robot message was. That was 5:18. Oh, it's 5:27. YouTube is good again? Okay. Okay, looks fine. Thank you very much. Appreciate you guys. Yeah, I'm starting to believe that this is the right chip. Why obfuscate this? You know, they found this chip, and I guess they didn't want anybody else to find it because it does sort of the special task of replacing a supermatch transistor pair, of which they would have to buy more than one. They'd have to buy a couple of those in order to make the circuit happen. And they found out through research and effort that there exists in the RF world a combination of 5 of them. And so they decided to use them and simplify the parts list of their device, which is a totally valid thing to do. We just kind of take personal offense to this sort of thing because, you know, we reverse engineer things. So that's, you know, I don't know. People think it's totally evil, and I guess it is, but they're just trying to make their special thing their special thing. They're trying to keep people from evil, dirty reverse engineers like us, you know, mouth-breathing idiots, from coming in here and using a rough highlighter to make a digital representation of their whole circuit. And it did take us weeks to figure this out, so their effort is not misplaced. What I'm trying to say is I don't know how to feel about this. I don't know how to feel about this, because we could easily do our own work to recreate the circuit. What are my hard drives looking like? Have I totally filled up all of my hard drives? Is that what's going on? Local disk C, properties. I dumped the streams onto local disk. It's like 20 gigs free. It's not a great situation, but I should have enough to finish out stream. I guess we'll finish out here. I think we identified the part. I'm going to look at a little bit more of this and maybe see if I can figure out some more of the stuff, because we're at time here, and I kind of want to end today so I can work on other stuff. But we're getting close to figuring this out. We've learned a hell of a lot today about the circuit. I've got all my notes, and we've got. I'm putting a lot of confidence in this being what we're looking at. That all these transistors are all of these circuit elements in this area, because in this area, because it certainly looks like that's what they're doing hardware wise. We've got 6 transistors here with capacitors in between them, with what might be precision capacitors in between them. We have a chip that might be a super matched quintuple transistor, and then we have 3 loose transistors sitting down here. So overall, from a bird's eye view, it's looking like a transistor ladder filter is all of this, and that center IC, it's not an ASIC of any type. It is just a bunch of transistors in a trench coat. Pretty cool. So, all right, we will get to the bottom of this. If not on Thursday, soon. We'll get to the bottom of this. Yeah, that was an eye into everything that went through my head 2 hours ago when we were taking an intense look at this and probing around. I had a suspicion that was it, but we needed to trace out voltage in order to separate out and say, okay, there's like 5 volts there, but nothing is going directly to the chip. So it seems like we've got multiple pieces of information that are sort of painting the picture for us, and we have moderate confidence that it's going to be a 5 transistor super matched RF chip. I have those. When you put one in, if it blows up, it blows up. It might be that something up the line blows it up. That'll allow us to continue on without fully reverse engineering the whole circuit, which is still something I want to do, but that's going to require a little bit more like book work. It's like stuff that I don't want to sit here all day. You guys might find it fascinating and put individual components into this thing and say, oh, this is connected here, here, and here. That was like my job. It was a job that I did. I can do it again. If we can avoid it, that'll be cool, because we can get this thing back to Dave. And then once it's back to Dave, I can figure this out on my own. Because things seem to be going pretty well in line with the schematic of the TB303. We've got a very, very similar circuit here. So, but yeah, that's closing time for me. So if you guys catch Sid Heresy on, or did we have any other events today? We had a couple subs. Dr. Plugger subbed, Pyro S subbed, 3Mares subbed, Cilia Russell subbed. Cilia's a 79 month. Man, 3Mares, 68. Pyro S, 64. These are the big, this must be an anniversary of my either partnering or, I don't know. And then Dr. Plugger was 49, which is impressive. That's still big numbers. You guys are great. Thank you for supporting me through this. We are eventually going to get Burn the Subs working again. I will not forget about that project. You guys, I know it's been a while with it, but it all costs money. How's it going? Speaking of older names on here. And hello, any AI, yeah. Thank you for the YouTubers that hung out. I appreciate you guys hanging out over there in YouTube land. And, on Twitch, we have this command, which ends the stream. It doesn't automatically do it. I have to click end, but I can click end, and you guys can get links to stuff like Discord, where you'll find me, or Twitter, where I occasionally throw a little thing out. Maybe I'll like some maker that you can follow. I don't know. Whatever you want to do. I don't mind. I'm not a cop. But I'll be back on Thursday. So the next stream is Thursday. Don't know what we'll be doing. Things are really busy around here. Some people are flying to England soon, and then things will kind of mellow out for a little while. So I'll be able to really hit streaming. And in the meantime, my entire life away from stream is uploading that VOD channel. So those of you on YouTube, if you click on the regular releases, you're probably inundated with those freaking things daily. I'm going to do daily releases until I'm done this 120, and then I don't know, maybe I can go to the streaming section of the YouTube and move stuff over. But what I really need to be doing, once that 120 videos finish going up, it'll be a year from when I started, and then I'll be able to I came across a VOD that was really good recently, had 2K views on it. That's crazy to me. That's just, those numbers aren't real. It's wild to me, because we have 50 people in here, which is a pretty calm stream for me. We can get up to 70, at which point I'm like, wow, that's a bunch of people. I had to do an average 75 over a month, so I had like 100 people when I partnered, and that was years ago. We've kind of mellowed out, and unfortunately, I've hit a streamer plateau. YouTube is supposed to solve that, but 5-hour videos aren't going to cut it. I need to cut videos down into like half-hour little explorations, and then put those up on YouTube. So that's the next phase. We're working towards that. I'm going to get that archive up, and then I'm going to work on editing video. It's a lot of work because it's just me. It's just me here sitting in a basement doing it all. But thank you guys for joining me. I'm going to put this is usually where OctoJ gets the cane and he gets me around the waist, pulls me off stage because I'm circularly talking about this stuff. I'm going to go walk the dog, touch grass. I suggest you guys do as well. Have a good evening, everybody. And then I can't find I need to make like a big button to do this.